So check your. If you hit it twice, it might have done something kind of weird.
I think we're streaming.
Let's just make sure the description is what you want. Like, is this the? That's.
No, it fucked up.
No, let's give it a second. Let's give it a second. Hey.
Nice. Okay, we're live on both channels. Sweet.
We are so live. And then go to this one. We gotta pop out the chat.
Oh yeah.
Yeah. And then I'm gonna start posting the link to Discord.
Pop out chat. Hello everybody. Sorry, I got a little bit of a weird start here.
No problem. Let's see here. I guess I can get the link from a thing.
Okay, I'm gonna do both YouTube chats, I guess. So here's yours.
Yeah, you can just kind of do like one and then the other. It's yeah, it's just really tall because it doesn't matter if it's tall.
Wait, it says sign into chat.
No, it's fine.
Oh, I got it.
It's fine.
Oh yeah, okay.
Because you got the new link, right?
Yes.
Okay, so now duplicate that and then do another one.
Copy paste. Does that work? If it does.
But it's the same one though, actually.
Yeah.
So if you edit the link,
now I gotta go to
no, it's if you're gonna overwrite mine.
Oh, okay.
So just make a new one.
Okay.
And I think it was 600 wide.
Okay. 600 wide. And where is our pop-out chat?
How do we
get the
how
link?
do I get?
And then OBS pop-out 600.
Okay. I got an idea. Put that one in the middle.
This one?
Yeah, put your chat on the bottom layer. Put that at the bottom layer. And then put GoPro between. And then you don't want to be at the very bottom because it'll never go away. Like right there, up. Well, yeah, so right there is where it'll start scrolling from. And then I'd probably move GoPro up a little bit so you have a little bit more chat, but that's fine. Cool.
Yeah, we can adjust it as we start to get messages too.
And if anybody's in chat and wants to say something in chat, that would make the process of us adjusting chat substantially easier.
It would make it easier. But I think we got a decent amount of space on both people's stuff now.
Okay, so I got a link. I'm going to post that up.
Yeah, I'll post my links too.
How's everybody doing today? I think we're probably working in both spots. Wow, screenshot that.
Yeah, our channel seems to be doing fine too. Okay. Well, we're good to go.
I'm just posting some links up in here. So, how are we doing, everyone? We've got open beam interface going real nice. We got what else? What else did we do on our last stream?
Well, we figured out why V7 wasn't working. It was very.
Figured out why V7 wasn't working. So V7 non-standard mod.
Yeah.
First of I think several we're gonna find on this platform.
Yeah.
So V7 was connected to the gate valve, which is it's not. As a feature, I don't mind it actually.
Yeah.
And I might do that more maybe. Like it's like kind of a little bit of an X-ray interlock, but I mean I don't like trusting a pneumatic valve to actuate as like your extra interlock with like no other like sensing the valve position or anything is like suboptimal interlock design for sure. But you know, added layer of protection.
We diagnosed 2 of the issues, or we think we figured out where 2 of the issues were coming from with our instability. Sorry, my brain just crashed. It's been a long night. One of the issues we think is probably just general cleanliness, and then
Yeah, we'll show that one. That one's fun.
we also have a really weird issue with where did you say that was coming from again? The other instability mode?
Oh, the collector?
Yeah.
Yeah.
Yeah, the collector's acting up. So
okay. I think I got this all posted up.
sweet.
Sweet. And then I think I can have this open here to just make sure YouTube is working.
Yeah, I'll keep my chat open. We can each monitor our own chat. I think you're probably gonna have all the chat activity today.
I've seen a lot on your channels too, though.
Yeah, but it's usually just monochroma.
We'll see if monochroma makes an appearance. Oh, I like that a little bit smaller.
Martin stops into my streams a lot too.
Yeah, we could just tag them.
Not a bad idea.
Can you not? Okay, I've only got the mobile app. Okay. Oh, the chat will be there. It'll be fine.
Sure.
So let's get Open Beam running here, shall we?
I'm gonna adjust this camera just a little to be more of a.
Oh, I'm not anywhere. Did I click enter? I think I hit enter. I did not hit enter. I was like, this seems like slow to launch. And it's like, no, you actually just never launched it.
That would do it.
That would do it, wouldn't it? Okay, we got 5-volt set port A and B, and we can start our live scan. Ooh, it's doing the collector instability.
Oh, nice. That just happened right off the bat.
Yeah, well, I mean, the micro's been running for a bit.
That's true.
So
It doesn't look quite as bad. It's definitely still
we're
bad.
scanning. Well, we're zoomed out and we're scanning fast.
That'll do it. Yeah, this should scale with mag pretty horribly.
You mean great, right?
Oh, yeah.
if you're into microscope problems. Oh, and then we objective aperture is really far off because we were playing with that.
Oh, yeah.
Oh yeah, we should show that to chat.
Yeah, that'd be a good idea.
It's hilarious.
So the computer's also has done the thing now.
The computer has done the thing. We have multiple things that this thing can do. Isn't that like a term in robotics, like the thing, where you're like, if the robot can tip or get into like an unstable, unrecoverable orientation, it will, and that's called the thing.
Yeah.
Okay, so
This is good at things.
it's not round. Why isn't it round? It should be round. Do you want to move the objective aperture around?
Yeah.
Around, get it? So so check out what happens as you move this around. So we do lose it, but see, check out all that interaction on like the side there. Like none of that is right. That's all
distorting a ton.
Yeah, that's
lensing
all
on it.
sadness is what that is. So that's like electrons are hitting things they shouldn't be, basically. And then let's go ahead and okay, so we'll stop our scan. That'll get us computer control returned. We'll zoom in. We'll go to PF2, page to speed. Almost had it. Speed 2, and then We're just going to lower the accelerating voltage, I think.
Okay.
And that's going to put us into a condition where we are more sensitive to charge up.
Oh, interesting. Yeah, makes sense.
And then we're going to go, we can start our scan up. And then we're going to go back to rapid so that we can over unzoom. So go ahead and try playing with that again. Or, and actually, before you do that, I want to change probe current. I can't change probe current. Okay, go ahead. Oh, look at that on the left side here. Oh, look, there's a whole little thing being like, there's a whole like chunk of the beam being taken off and put somewhere. Look at all that. I think that whole edge is like charging. Oh man, look at that chunk of something.
When you use your column as the beam.
Right? Yeah. This is called a structured illumination.
Wow.
Hey, we got somebody in chat. Who's in chat?
Tea Cakes, I think, said hi.
Tea Cakes. Hi, Tea Cakes. Welcome to the streams. We got 6400 here. What did we do?
Well, I just tore my jeans on a jumper. Let's hope that's fine. Nothing blew up or cracked.
Okay.
So.
Do you want to lower... go ahead and set all the manual switches down except for RP, which you can leave up. Yeah, I always leave RP up so that if manual does go on, it doesn't open up LV4.
Yeah, that makes sense.
Yeah, if the RP goes off and V2's up at the same time, that's a very sad day. Yeah, let's I'm gonna let's do slower dwell. I just want to find the worst right now. I'm sick like that.
I'm gonna switch OBI to our main screen since
and then, I have another. I have actually just go ahead and duplicate that. So
this.
Yeah, duplicate that one because we made a bunch of other changes. And then flip the two around on that. Yeah, cool. Okay, what are we saying, Discord?
We are doing very great. Thank you. It's been a long week, but we've been doing just fine.
It's been a long, fun week.
Yes.
Okay.
That is an important distinction.
So I'm zoomed in. We're going to just crank our probe current. Absolutely. Well, that was focus. So it's like, there we go. Probe current cranked. Go to the PC3. We'll start our live scan. Now we'll move our objective aperture around. Let's see what we can't discover. So
that's supposed to be a circle, right?
Yeah. Sometimes with a lot of probe current, you charge up the contaminant so much that it like kind of goes into like a steady state, basically. Oh,
interesting. It is kind of getting. Oh, you're moving it. Okay. Like we have our collector instability as well right now.
Yeah, and then and not only do we have our look at that in the top right corner.
Oh my gosh.
That's doing great. Doing great if you're a connoisseur of microscope image distortion artifacts.
That's why I got into this.
Yeah, look how soft that is up there. That's hilarious.
That's wild.
And then the really funny part is like the only reason we can zoom out this far to even see this is like another problem with the microscope's computer locking up in certain like external scan conditions.
Yeah, you're not supposed to be able to zoom out this far.
Normally you have to do like a manual memory command. This is very entertaining to me. I am thoroughly enjoying everything about this, and I shouldn't be, but I am. We might be able to resolve that a little bit easier. I'm going to bring us to 8mm.
Is that okay with our tilt?
We're at
13. Okay.
I think we're at like nothing, but yeah, this is okay. 15 degrees is our limit actually.
Gotcha.
Let's try just going further away actually. Okay, so further away actually will highlight things in a little bit of a different way. Oh yeah, you can see the interaction with the. So we're able to You see how we're changing that lower charging artifact
Oh yeah.
with the objective? It's kind of, I think it's being spun with it.
Yeah, looks like it.
So that probably means we're like a little bit above, a little bit below.
So contamination everywhere. I
Yeah,
will say,
yeah.
like, with how dirty the anode was and with how dirty everything else was in the top part of the column, it does not surprise me. Like, after I cleaned that, I got like an order of magnitude more magnification out of this
Okay,
thing.
so here it's moving some, but it's not moving a ton.
It's really getting pinched right there at the
Yeah,
top.
it really is. So there's a big chunk of something there. Okay, so this.
So interesting.
Yeah, wow. Look at what it's doing there.
Yeah, I've never
Yeah.
seen something like that.
Yeah, like all that right there. That's really cool. Sorry.
No, you're fine.
Ah. Excuse me. And let's just verify it's not part of the stage. Always good to verify that what you're seeing is real and not something you're imagining.
Yeah, it's definitely hanging out in the same spot.
Yeah. Oh man, look at that. That is so cool.
Jeez.
Okay. Here, let's really blast it. So I've changed to a different objective aperture so we can just kind of test to see if this is an issue with the aperture. And it looks like I'm on a completely different aperture and we're seeing very similar behavior.
That's a good idea, though.
And let's go down to our other one too. Yep, our other one is also still there. So I'm calling the other one the one on the bottom edge right now.
Okay. Yeah.
So that's still there too. That didn't
Definitely.
change with aperture. I mean, it does change when you move the aperture, but it's changing because it's like, okay, so I've removed the objective aperture completely now. So moving it, well, I guess you kind of can move it still some. So now we're just kind of seeing all of it all at once, and you can see just like how blurry our like lower left edge is there, like. So that is our collector instability there.
Yeah.
Wow, this is like such a uniquely bad like image. I'm so entertained by this. We're saving that.
When I'm in an abstract art competition and my opponent is this JSM-6400.
Mag 50.
It's so wild.
At least it's cool.
Yeah.
Okay. Love that for us so much. Okay, actually we're gonna do hold external control so that we can over unzoom in the way that we're not supposed to be able to. Wow. Actually no, we have to, so we're gonna release, we're gonna zoom in, okay that cleared, now we're gonna hold, now we're gonna zoom all the way out, and now we're gonna acquire.
Wow.
Okay, chat. We got a lot of people in chat.
Oh, damn.
What is chat up to? Structured illumination is right. Gotta be a hair or a tiny piece of dust.
Yeah, we're thinking.
Or Martin sneaks some wood in there while Digimon is distracted.
Right.
And whatever that must be in the sample holder is changing with sample rotation. So we weren't actually rotating the sample TKs. We were
changing focus.
We were changing focus, and due to electron spin precession, when you change focus with or change the strength of an electromagnetic lens, you rotate everything because
Oh.
it spins. So that's why I was rotating with that, is the objective
Okay,
was
makes
spinning
sense.
it. It wasn't quite spinning it at the same rate as scan, but that's you kind of like spin as you go through the objective. So, and then there's also some other kind of like nonlinear effects, like maybe part of the field gets out of the lens, so you do a little bit of rotation outside the column too. So there was a difference between how it was rotating with the objective and how the image was rotating.
Yeah.
But basically, if there was no change, it'd be below the objective. But there isn't really much below the objective, right? Really, what tells me that we've got this issue below the objective is that we're moving the objective aperture around.
Yeah.
And move the objective aperture around, we're getting we're able to like interact with it and see it differently. So, okay, so that's that issue. We could spend a long time looking at that.
Yeah.
Probably shouldn't.
Yeah.
Because we have other problems to explore.
And we're planning on cleaning anyways at some point. So.
Yeah. So that's contamination. So what do you want to dive into next?
I need to
Collector?
go check my note because I left it on my computer.
We could pull the collector PCB out.
Okay, we can do that. I'm gonna go take a picture of my note regardless, just so we have that on
Yeah,
the list.
sounds good. So another one of the issues we've been seeing is let's see here. Okay.
Instability from the stigmator is another one.
Yeah. I can see the collector one right now. Oh, that got bad. Look at that.
Yeah, it tends to get worse, I think, the longer you leave it, but I haven't left it for too long.
God, this is so much fun. Can you give us, go back to objective aperture 3?
There you go. Toasty.
Yeah, so this another thing we can do to verify that this is collector is we can change the accelerating voltage.
Okay.
So at lower voltages, we're going to be substantially more sensitive. So go to 500 volts.
Oh yeah.
Yeah.
Yeah, it's shredded.
That's a great way to describe that. Do you ever wake up feeling like this?
I did this morning.
It's funny what Leon Engineers will do. So 500 volts, 25x, stock life scan, acquire photo. We'll mag out all the way, and then we'll acquire another photo. Oh, I guess that's not 25 anymore, but that's fine. Wow. Okay, so then let's go ahead and we can just watch as we do this. So we'll just click up. Well, let's go to 5 kV. So 5 kV. Look how much better it is, right? All the problems are fixed.
Done. And it was just that easy.
It was. We are also live, by the way, so you're aware.
Yeah.
Say hi to the chat.
Hi, Chad.
Okay, so now we are at 5 kV, right? 5 kV, and then now we're at 20x. 5 kV, 20x. Okay, so let's do acquire photo. Okay, so acquire photo. So now let's go to 10 kV.
What?
What's the name of the stream?
Oh, it's on both of our channels. It's on Nanographs and Bionanomics, so.
On YouTube?
Yeah.
Okay, so we increased to 10 kV, and I think that looks a little bit less.
Yeah, I agree.
So that's scaling linearly. And now if it's also collector, what else could we change? This is a quiz. What else could we change that should, like what's another thing that we could use to like scale this if it's collector?
Let me think about this.
So electrostatic field in the column, making things like vibrate, right?
I'm trying to think of the other condition that triggered it last night, and I cannot. My brain.
So that's
is
a
too quick.
triggering thing. So that's kind of
Okay.
that has to do with you know, what actually induces it.
Okay.
But what can we do to like change the scale of it? I mean, we could try to like make whatever's causing it worse. So it's an electrostatic field in the chamber causing beam deflection. So drift distance.
Okay.
So if we increase the working distance, we have more drift distance.
Oh, I see. Yeah, that makes sense.
Yeah,
So there's more
yeah.
space for
There's
the beam to deflect. Okay.
Exactly, exactly. So let's go ahead and drop our working distance.
That checks out. Where do you want it?
Are we at 48 right now?
Yeah.
Are we?
Yep.
Really?
Yep. Now we're at 39.
But we were focused, our working distance, okay, the software was pretty far behind. So let's bring it closer, actually.
25?
15.
15. Here you go.
Lot better.
Yeah, it really is.
Lot better. So that's we got beam coming down the column, or beam coming out of our pole piece. Sample. Our collector is like over here. Voltage in the collector is going up and down, so that's moving the beam around.
It makes a lot of sense.
Yeah.
Which board is the collector on again?
So the collector is kind of in a, well,
Or the board that applies the voltage? I guess.
yeah. So okay, so the collector voltage is generated somewhere, and then there's a board that like steps the collector voltage down
Okay.
with a bunch of relays. So 20x WD 14 millimeters. So stop live, acquire photo. Cool. So we've got a lot of stuff pointing to collector right now, which I like having multiple things like all pointing in the same direction.
Sure.
Yeah, so that feels pretty good. Yeah, what?
Where's the battery?
Where's the battery for that? Battery for that. Do you want to say hi to chat?
Hi, chat.
Oh, they're charging.
They're up there.
It won't quite. You can close it. You can open it, but it won't. The battery still won't come out because of the. Yeah. Maybe. Obvious. Okay. Oh, sweet,
Wow.
sweet. Real professional here. So we're gonna be moving around to the back of the microscope. Do you want to help us rearrange cameras, or?
Yeah, sure.
Cool.
We still have no signal on that? Oh, no, it's
So I'm gonna start getting our control console cleared out. So we want to avoid this area. See this area with exposed stuff in it?
Yeah.
Do not go in here.
Okay. What would happen?
There's exposed AC voltage because Joel made interesting choices on their design. I know, right? You know what? I can actually swing this out pretty far. We're gonna be moving this cable here.
How the
And then if you
hell?
want to bring the R6 around too, I think that'd be
Okay.
cool.
Yeah, I'll put this there.
Oh, do you have any video lights?
No.
Okay.
Not readily accessible.
There's some down in the room by the lathe room has like 3 video lights set up in it right now.
If we could just get like one light, that would be cool.
Sure.
But
You said it was in the wood room?
The room right by the lathe with the glass window.
boop, 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 boop.
Sweet. You should have a lot of length on the M6. I just got that cable all untangled.
Okay, cool. We got a lot of length on the R6 as well.
Cool.
How do you like how opened up that is?
Beautiful. I've never been able to swing it out that far because we had the dent in back here.
I do not mind not having the dent in here.
No, I don't think it's going to be coming back into this section. I'm going to figure out somewhere else to put it.
Have you seen the long flat flashlight? I got it.
Okay.
Oop. So that's.
Is that power
Easy.
off right now?
Nope, everything's on right now.
Okay, so I should probably turn that off. Or are we gonna leave it?
I'm gonna tap it a little bit. Is my kind of intention right now.
Okay.
So we're gonna increase our working distance because that was a good condition. We're also gonna decrease our accelerating voltage. We'll go to.
We'll use this guy as
3.
the little macro because it's tiny.
Yeah.
Get it back here easy.
Start our live scan. Change our focus. It's gone. No, there's something. What is the something? It's not as bad as it was, whatever it is. Why is it not as bad anymore? Is it because we went below 5 kV?
Probably. Very nice. Thank you, sir.
Mm-hmm.
There we go. Amazing image quality.
What?
Amazing jagged image quality.
Yeah.
Yeah, that's what's wrong.
That's how it's supposed to look.
You know, tell me if this changes when I tap on something.
Sure.
There's a little more light for you.
Cool. So that's our collector box right there. Okay, ready? Anything?
No.
No.
Nope.
Yeah, it looks pretty similar still.
Okay. Well, it's probably a pretty good time to go ahead and we're gonna go OPE off. So let's go ahead and ramp filament down and
Okay.
acceleration voltage off.
All right, 1 sec.
And then you wanna tell me what chat's up to? Okay, are we acceleration voltage off?
T-Cake said microscopes hate this one simple trick.
What, tapping on them?
Yes.
Yeah.
Was there supposed to be a... Oh, it's OBI just went like solid white, but I'm assuming you
That's
disconnected
because
something.
the control console power's off. Do you want to switch to R6 main?
Oh, yeah. That's a good idea.
Oh, just undo that because we have two.
Oh,
we
yeah.
have yeah.
The...
We're like set up.
Yeah. Oh, weird. They're both...
Up one.
What?
Up one.
Yes.
Cool. Okay, so we are OPE off. So, just so you know, there is still AC voltage in this box, by the way.
Okay. Where at?
It's the power switch.
Oh, well, that makes sense.
Yeah, so it's that connector right there.
Okay.
And there, yeah. So we're just gonna go ahead.
You're just taking the collector box off?
Yep.
Okay, cool. I'm gonna move this panel so I can sit beside you down here.
Okay. So the top two screws in it are, check out see the shape of the metal there? So you don't actually have to loosen those ones all the way.
Oh, I
You
see.
just got to loosen the top two. So I've left that one in
Okay.
to keep it up
Sure.
while I loosen the top two. And then once I pull that out, we'll be able to slide it out.
Cool.
So now I'm supporting the weight of the box. haha, your collector belongs to me now. Okay. There's another one for you. So these are all of
Here, let me get the.
Here, I can show this one.
Oh, perfect. It's in manual focus.
Yeah. So it's just a voltage divider, you know. So it's literally, we've got all these like moderately high voltage relays, and and then we've got our resistors, and so we can just like change how many resistors we have in our circuit to do the voltage divider, and that's what changes the collector voltage. It's pretty simple, you know, really, when it comes down to it. I'm just gonna check the cable that actually departs this box. Do you have a spare of these, or?
Of the collector box?
Yeah.
I don't think so. I need to go look. It's possible I looked at it and didn't know what it was and put it in with all my other spares, but I don't remember one that's that exact shape.
Okay. So we've got a couple of ways we could proceed here. Things I'm thinking about, we could just turn it on with the box in our hand, and then I bet if we tap the relays, we'll find one that when we tap it causes challenges.
Do you think we just like have a bad seated connection or something, or the camera?
Yeah, it's possible. And then the other thing we could do is I want to just get to the back of the board and be like, do I see something?
Sure. Okay.
It does seem very possible that I will just see something. I think I'm going to just go ahead and get to the back of the board to start with. Here,
I'm gonna come around and film with that camera on this side.
Okay, sounds good.
How's the R6 view? Let me see. It could be better. There we go. I got you.
You got it? Cool.
Yeah.
You know, it might actually be easier to just leave the standoffs on the PCB and then go ahead and pull it off from this side.
Oh, interesting.
So it's, with an issue like this, it is actually still possibly a digital issue, not an analog issue. And by digital issue, I mean, do we have a screw container back here?
Yeah, I was just using my back pocket for these.
And by digital issue, so we've got that, you see that ribbon cable, top left corner of this box right now?
Yeah.
The gray, green, and red one?
Mm-hmm.
That is the bits, the digital bits that control this box.
Okay. So something coming in on that line could also be throwing off the signal?
Theoretically, you could be controlling a relay wrong, or you could be like flipping a relay on and off really quickly or something like silly like that. And then as you change the resistance of this box, you also change the amount of current flowing through it because we're changing the resistance.
Yeah.
So it's also possible that we actually have a power supply issue, the high voltage power supply, like further upstream. And it's when we're changing the load on that power supply that we are experiencing challenges.
That could explain why turning the power supply off and back on usually fixes it.
Yeah, and I mean, the relays also kind of behave in a somewhat similar fashion, potentially in failure modes. Okay, I am just doing a very close visual inspection here. Haven't found anything yet.
It looks fairly clean.
It does look pretty clean. I'm also looking for like a cold solder joint. That could also explain our symptoms. So just like a solder joint making bad connection.
Sure. I'll check the chat.
Yeah, what does chat think? What does chat think is going on?
Nothing since.
Nothing?
Oh,
Chat,
wait.
you disappoint me.
I lied. My phone locked up.
Okay.
Cake said, I have to say this microscope is coming along nicely. I've been offline for a little while and the progress is really cool. Hey, thank you. Adam has been here helping me a lot this week. It's been really great. Oh yeah, it does. It did look hairy. It's a good way to describe it, Spirit. Spirit says the image looked hairy.
Right?
Why is it working now, right? Well, yeah, Adam brought a couple of their cameras. This is kind of like a hybrid stream setup. It's kind of combined between both of ours right now.
Okay, I have not found anything jumping out at me visually. So another reason I'm suspecting this box is and we can hear a relay click associated with when we like start experiencing the issue versus not experiencing the issue, right?
Yeah, only pull below a certain mag
So
level.
the collector changes for a couple of reasons. It changes for acceleration voltage, and it also changes for working distance. Because when you're closer to the pole piece, you want a little bit more collector voltage because you're working harder to kind of like extract the electrons. Because you got like a short distance between the pole piece and the collector.
Okay.
And you want to kind of pull them away before they hit the pole piece, basically. Oh. Is
What you
that
got?
a cold joint, maybe? Or is that just, no, all these joints look great on this part.
Deoxit to the rescue, T Cake says.
Well, everything's soldered in here. There's no electrical. I mean, I guess there is some electrical connections. Like, you do have that one right there on CN4. So, like, if we had an issue in there, deoxit could help. The relays are probably sealed. If somebody in chat wants to be really, really, really useful and look up what a LAB1N dash, and this is the hard part to read, dash V07.
VDC.
I think it's V07. Oh, that's 5 volts DC.
Oh, okay. Yeah. Sorry.
So there's two parts to the sticker. There's the dark black text, which is like printed on all of them, and then there's this like really light,
now I see it. Wow.
Yeah, really light text. So there's the 5 there. There's also the dash V07. So those are kind of like how this particular one's configured. So this has got like a 5-volt coil in it. Okay, so pin 1 and 2 is coil. Pin 1 and 4 is coil. Pin 2 and 3 is switched. Yeah, interesting. Okay, so if I recall correctly, and I could be wrong here, but if I recall correctly, we've got 2 voltage rails coming from our power supply here.
Okay.
And we got our A and our B, right? And then it's, I think the way they have it set up, because you can change it based on like what resistors you have installed and not installed, is that A is set up to be kind of controlled by VR1, and then I believe that just goes. Well, maybe they're both on the same one. Oh no, they cut the trace, chat. The trace that's been cut. So that's how they're setting it there. You see that
Okay,
chunk
yeah.
of the trace that's missing? That's kind of fun. And there's been some other stuff installed in the back, because of course there has.
Sorry, I'm gonna steal this out from under you.
No problem. So yeah, I'm not finding huge issues. I mean, there's like a lot of sharp points here, but our collector voltage shouldn't be enough where that really matters. It could be. I just don't think it is. I don't think that's likely. So we also have this capacitor like on our output here to kind of help smooth things over a little bit. That capacitor could be failing, but it's just behaving so specifically at a certain switch, right? That makes me suspect of that. So I think what we're gonna do is put this back together and go ahead and
Tap on some stuff.
Yeah, we could tap on it, or we could use like a permanent magnet. We can get it close to the relay.
Oh, that's not a bad idea.
And that will trip.
We
the
brought
relay.
some magnets in here earlier, right?
That's actually what I was using those for.
Oh, nice.
Can I get 4 of the screws back, please?
Yes. Let me set this camera down for just a second. They were the littler ones, right?
I believe so.
There you go. I have one more. All right, here's all the rest of your screws.
I'm not going to fully reinstall it.
Okay.
I'm going to leave it out so that
I'll take the big ones then and keep them safe.
Yeah.
Should I turn power back on?
Not quite yet.
Okay.
I would like to not have my hands holding a box with high
Really?
voltage flowing everywhere on it.
That's not very fun.
Sorry for being boring. When, not now, but when we turn power back on, if you just want to go ahead and procure a beam for us.
Yeah, I can find a beam.
That would be great. So if I'm not mistaken, the collector voltage comes from the rightmost ones of those power supply boxes.
Well, I do at least have an extra one of those.
Yeah, I think you have an extra 2. Well, they are.
One's for the monitor.
Well, kind of.
Okay.
I'm trying to remember if that one only does the monitor, because it's like it actually uses the same 10 kV for the monitor and the scintillator.
Oh, interesting.
And then it's got like a bunch of other stuff inside of it too. It's just got like it's got multiple power supplies in it. Some of them are all like some of them kind of get derived off the same stuff. Some of them are their own thing.
Okay.
I'm having trouble getting this screw to line up, which is
try
interesting.
with my fingers, or
It's like I can see the standoff
yeah, it
not lining
looks
up.
good.
No, it doesn't look good.
Oh,
It looks
okay.
like off to one
the
side.
angle I was
Yeah.
at looked weird.
So it's like that's interesting to me because like maybe this circuit board is being held under tension, and maybe that was causing problems.
That relay is discontinued since 2012.
Okay, what's the voltage rating on it? Is what I'm really curious about.
TK said might be magnetically shielded. We'll see. We'll see what the chat says about the voltage.
So this one standoff is giving me like a little bit of an issue, so I'm just going to loosen it so that we can move it around some. So I could foresee this being a case of we were like I wasn't the PCB is being like a little bit excessively flexed.
Sure.
So the reason I don't think it's digital is it changed with a relay click. So if we did have a digital issue that was making its way all the way into this, like, you know, you could be like, well, maybe there's some kind of ground loop, maybe there's some kind of like weird signal coming in over the wires.
Sure.
Unlikely, I'd say.
Yeah.
If we did have a digital issue, it'd probably be like flipping the relay is what we'd hear. I think like it's possible we have something else, so we don't want to rule things out unless we know, right? But the most likely direction I think for troubleshooting is going to be I think this is a mechanical issue. I think this is an electromechanical issue is where I am currently at. But definitely want to be careful to not bias myself too much here. Get it? Bias? For biasing the collector. Haha. Okay, we got the cable that controls this back end. So this ribbon cable just like goes. This one just goes to a card, right? This one doesn't actually. Does this one go to the backplane, or the backplane? Does this one go straight to the card? Oh, this one actually does go to the backplane. This one goes to CN8 on our backplane
Okay.
here.
T-Cake says some 5, some 12, some 24. Coil rating. Switching rating
yeah.
estimated to be 125 AC or 60 DC. And then somebody else,
60?
Joe Mama 555 said use the sonic screwdriver.
Yeah. So 60, 120. Okay, yeah, this is going to be fine probably. So 60, 120, 180, 240, 300, 360, 420, 480, 540, 600, 660. So yeah, I think your maximum collector on this scope is 400 volts. So they're probably a little bit under the maximum rating. So we're probably not exceeding things too terribly. Let's see here. Oh, this is kind of actually. I think this one's actually a. So I think the resistor chain is basically constant on this. So it's like I think you're always flowing current from here all the way around through all your resistors basically. And then you're changing which one is getting tapped, like where in the voltage device is getting tapped and sent out. So that actually shouldn't change the load that much unless there's like another voltage divider or something coming off of CN or before CN4, which there was that resistor on CN4. So that could kind of change, like depending on where you put in there, the series resistance could change. Some of that could change the load, but I don't think that's how this board is designed. We should pull the schematics up for it in a sec.
Yeah.
And then interestingly enough, the first two don't actually have any resistors on them.
I see that.
So that is
I also have the
curious.
schematics digitally if we want to show stream a little easier.
Okay, yeah, cool.
I'll pull those up on the computer real quick.
Okay,
Sorry.
sounds good. Actually, before we do that, let's go ahead and get
power.
Yep, let's go ahead and apply power. Let me set the box down before you actually apply power.
Okay.
But if you want to get ready to get a beam, I can apply power.
Okay. Yeah,
You want to get by me?
Yeah, sure.
Cool. Okay, so let's go OPE on. OPE on.
All right, there's the microscope. Well, the OBI just started scanning immediately as soon as the scope came on.
I think, oh yeah, it's because OBI is powered off of the.
Off of the scope, I forgot.
Yeah.
Well, the server came up and everything, like it's connected.
I think the server was already running.
Oh, it was already
still.
running, yeah.
Yeah.
All right, let me get a beam. What voltage do you want to be at?
10 should be fine.
I'm not getting any noise out of this, just a flat signal.
What's your probe current? You're at 3, so you're two. So your PMT link is keeping your contrast too low.
Yes, I see.
Can I get a HDMI?
Absolutely. Sorry.
No problem.
Okay, cool. So, that looks pretty good. I'm gonna go a little lower res. There we go. Okay. think we're saturated. I'm gonna double check with EMP. Maybe not.
How's saturating going?
It's okay.
We don't have an issue yet?
Well, okay, so I've saturated here. Let me just get it. But then if I go to EMP, the beam doesn't look that good.
Increase contrast. Are you at false peak?
I don't think so. I think I'm way past it. Here, I'll decrease so you can watch what happens. I think that is false peak right there, see? And then this would be true peak right here.
I think you can. I don't. Are you fully saturated or not? Our spot size is 16. Take that up some. Oh, well, it's effect. Okay, so when you're in EMP, it changes OL fine, which is changing OL number, which is changing condenser lens number 2, which is basically zooming our emission pattern.
Okay.
So set OL fine back to 0. Oh, it doesn't actually matter. Just go back to regular and then change our. You can do it with the yeah, that works too. Now get our probe current up to like, I don't know, 10. I don't think this matters really. Actually, no, it does make me go into EMP, so that wasn't what it was. So go back to EMP. And I'm just gonna
go for it.
real quick.
I could have messed it up. It's definitely possible. That does look tighter, but oh, okay, that was your false peak.
I think that's saturated now.
Okay.
Let's see here. What is the chain of relays? So the chain of relays is a voltage divider for the collector or for the collector voltage. So what do you normally do to make the collector upset?
Anything. It can just start or like randomly, or it'll happen. It honestly just randomly starts out of nowhere. Like,
Okay.
I can be working on it for 2 hours and not have an issue.
We can go back into regular EOS.
Sometimes
so if you just hit the SCM button.
Oh yeah, duh.
Yeah.
And sometimes as soon as I boot it, it happens immediately. So.
Let me pull up the schematic for this just so I can show chat here.
Do you want a digital copy?
Sure.
See, I'd have to log into my drive actually.
Yeah. Collector PB, page 41. I think that's what this is. 'Cause I was like, there's no collector PB in the rack. Yep, there we go.
Here, I'll bring the M6 over so
Sounds good.
you can see this. Whoops.
Oh, you know what we could do? We should just be able to actually just straight up go to... No problem. No, they're both powered off that. Oh. Where's a good pointy thing? the wide one? I have. So this right here is our ribbon cable that came in. And then we got a 74 LS240. It doesn't say 74, that's just what it is though. So we got a 240, what is that? Quad something, I don't know. And then that's like a hex decoder. And then, so, okay, that's our ribbon cable. These are some of the logic ICs. These ICs are isolating, I think, or these are basically, these are acting as our relay drivers. And each of these controls 2 of the relays. These are the relay coils. Those diodes are the anti-flyback diodes. So JE6, JE8, that is what, oh, actually, JE6 and JE8 are right there. So we got plus 400 volts and right, okay. So we have the plus 400 volts and the minus 400 volts. So why do we have plus 400 volts and why do we have minus 400 volts? So that's going to be, I think it's page 3. Yeah, okay. So we have collector can be off, on, or suppress.
Oh.
Why do you think we have suppress?
For... I don't know.
When you're blasting.
Okay, like
when
40 kV?
Massive probe current. When you're like doing like a lot of WDS, a lot of EDS, just tons of electrons constantly, and you're like, I have way more signal than I need, and I don't want to burn out my phosphor and my PMT prematurely.
Makes sense.
We can invert the polarity that's on the collector. So the way that polarity inversion is done, so we have JE6 is plus 400 volts, JE8 is minus 400 volts. Electrons are negatively charged, so the plus 400 attracts, the minus 400 repels. So we have JE8 come in here. We've got a relay that can flip in JE8, which is relay 10, or we can have it come in through JE6, and we have relay 9 that can flip in our voltage divider chain. So, and then we also have relay 11, which can ground out both of these. So that's going to be off. So if we do on-off suppress, 9, 10, and 11 is what's going to be being flipped there. And just to look at it real quick, let's go ahead and take a gander at what's going on inside of our power supply box. So we got our CSI, that's our camera unit actually right there. And then we have V1. V1 is that monitor. So these are both coming off of our 10 kV voltage multiplier here. So this is all CRT stuff like above there. So we want to see where this goes. So this comes into this box here, and basically that's a rectifying circuit off of a high voltage transformer. It's possible that's the flyback transformer. So this might be driven off the first stage of the flyback. So you see D8's pointing that direction, D9's pointing that direction, and we have a center tap on the transformer. I think, nope, no center tap. That's the node there. And then we've got some filtering stuff, capacitors and resistors for filtering. And then let's look at where our minus 400 comes from. Our minus 400 also comes from there. It's just changing. There's some relays to enable, disable that output. So relay 1 there is another relay that actually has some control over what's going on here. So relay 1 can turn on and off actually, I'm going to trace out one of these wrong. Yeah, okay, so it's nodes 11, node 12, node 13. Okay, so I don't know where JE1 goes to, that plus 400. I'm not sure, like, I don't know. I'll have to look at that, but I don't think that matters. JE6 and JE8 is what matter. So that's our power supply for that. That's the driver circuit for the flyback. I know this is a flyback, not because I'm like looking at it and it's telling me that. It's because I've opened that box and I've like seen it. Okay, so this is our voltage divider stack, right? So you've got, so this one's plus 400 volts, this one's minus 400 volts. Minus 400 is only used in reflect, so we don't need to tune that one. We're just like, do we want to reflect or do we not want to reflect, right? And if we want to reflect, we're going to reflect, so we just do that. There is a voltage divider and a VR2 here, so that you can kind of like tune the voltage there some. This one, we come in, we got R9, and we got our 1 meg voltage divider, configured potentiometer, or it's not even a voltage divider, it's just a variable resistor configured potentiometer. And then we've got our chain of resistors, and depending, so that's 0 volts, right? That's 400 volts, so we kind of, our potential goes down as we go through our chain here. So depending on where we tap the chain, we get different voltages.
Okay.
So let's, for the sake of just example, let's assume we kind of have like an equal potential steps across each one of these. So in the middle here, you'd have like 200 volts, and here you'd have like 300 volts, and here you'd have like 100 volts. You know, kind of, that we get that potential is changing across that.
Okay.
So yeah, so things that could be going wrong. If relay 11 was like clicking in and out or not fully disengaging, okay, when I say things that can go wrong, the obvious thing to me to go wrong is we have one of these making intermittent contact.
Yeah.
Just one relay clicking in, bad connection there, cool. I'm trying to think of other things that could be happening, just to evaluate that. We could have relay 11 or relay 10 not fully opening or making like, or only opening a little bit. If that were happening, we'd be like shorting, because you see how like the 400 volts and the minus 400 volts could be connected together through relay 10, right? Because we're both on that same node there. So we could have something where like this is like being pulled down by one of these other relays having a problem. Relay 9 could not be opening. So relay 1, 2, 3, 4, 5, 6, 7, 8, and 9 seem like, to me, most likely candidates for our problem here. Yeah, what's chat saying? Oh, chat has said things. Oh yeah, running the secondary in backscatter mode. That's another thing you can absolutely do. Could the whole flyback be faulty? It was the issue on your ISI, and it might be shows up more as a collector issue. So the flyback does a lot of different things. The flyback drives CRT1. The flyback drives I believe the flyback on this one is what drives the collector. Actually, sorry, scintillator. Yes, the flyback on this one is the one that drives the scintillator. I don't think it's the flyback. We don't get our voltage here from the flyback. I don't see anything on the CRT. And it happens with a specific relay click. Like when we get one of these relays clicking in and out, that's when we experience our challenge. That being said, there could be a change in the current we're using when we use one of these relays. And if we have a change in the current being used, that could affect the power supply like that. So I was really hoping that sitting here, it was going to just like mess up for us. But
Oh, start happening again?
Yeah.
Well, let's mess with some
yeah,
controls.
because another thing that was affecting was working distance, right?
Yeah. If we go up past
Yeah, like 61, I think.
yeah,
is
it
what
was
we were
60
finding.
60 to 61, yeah. I'm not hearing the click. Oh. I think it has to be happening for that to trigger it. Like, it'll kick in randomly through the HV, like when I'm using voltage, but last night it was already happening when we discovered that mode.
Well, it might be, because it might be like it's set up to happen. Okay, so let's leave it in a state where it's likely to happen, which is now we're at let's go to a short working distance.
Yeah, and we're above 5 kV, so we're already
Leave it at our short working distance.
pushing it.
Leave it at 10.
Try tripping external scan on and off a bunch too, because I've had it 4 pi when I would hit the external scan button. Sometimes it would cause it as well. But That would also make a huge relay click when I did that with 4Pi.
4Pi had big relays in it.
Okay.
Go ahead and raise the sample up.
What working distance?
Let's do WD, let's go 15.
There you
Go
are.
ahead, go to 8. Might as well go to 8.
Okay, should I untilt before we do that?
Yeah. You are technically in an okay range, but you can go ahead and untilt. Is it, are you hitting a hard stop or? No? Okay, cool. I have no idea if your tilt is calibrated correctly.
So true. I mean, the stage looks visually right when you put a sample on it.
But I'm going to go start tapping relays. Hopefully that induces it.
Sure.
And I'm not going to use something conductive to tap the relays because I am just like kind of poking in a high voltage box. I'm going to use one of my multimeter probes because
That's a good idea.
those are rated for this type of thing. I'll take that with me.
Sure. And I'll keep an eye out over here.
Sounds good.
We need those things that like hold the cables up on the ceiling.
I know. Or just like something along the wall that can like hook on.
Yeah, that'd be
as we're
nice.
Moving around. Okay, it's our favorite little collector PB. Ready?
I'm ready. Looks normal. Looking normal. Still looking normal.
Still?
Yep. Yep, looks, oh wait, there was a little bit of noise just there, but it wasn't that noise. It's like showing up as lighter bars. A little noise, but not the same noise. No, it's not. It still looks fine. Just throw it on the ground and see if that starts it. Like, it's definitely adding a little bit of noise, but I think that's gotta just be like acoustic.
No, I don't think
somehow.
so. That's
Or not acoustic, but
Is
like,
there one in particular that's adding noise?
I can't tell anymore. You should look at this really quick. Because it's kind of, it looks different than it looked before now. So,
Because if you're not,
now what I'm seeing is, see all these like white bands that are popping in
yeah,
here?
that could be a collector thing.
That was not happening before you started tapping.
That could absolutely be a collector thing still.
Okay. You zoom in or?
No, we're gonna change some scan parameters.
Oh, yeah, it's happening. Look at that. You can see the banding. Yeah, should I zoom in and
Yeah.
see if it scales?
Okay, zoom out. That might have just been like crap on the sample, kind of causing a. That might have been like a physical deposition effect because we're on like a bunch of carbon right here. I'm going to move the stage somewhere else. Can you increase our scan speed?
Yeah.
Okay, this should be relatively immune from any of that. Let's just rack our mag. Let's rack our mag. Can't induce it when we want to.
Yeah, no, it's really intermittent. I mean, it'll almost always happen during a multiple hour imaging session, but that's kind of the rate it works at.
Okay, I think we're just going to leave this box open then,
Okay.
and then we'll move on to investigating something else. And
Wait
then-
for this to start back up.
Exactly. You got the tripod for this out here?
Right here.
Ah, it just folds away so quickly and easily.
Right.
Oh, is it doing it?
No, I just was zooming in for fun.
Okay.
Our aperture's still way out though.
You could fix that. Just get yeah. Oh, you're gonna see how nice it is to do objective wobble.
Oh
with
my
this.
gosh. Oh, that is much nicer. And I can also like kind of turn. Oh, I guess I can't. I wish that'd be cool, but I'll just keep an eye on it.
Different monitor arm.
Yeah.
Or mount this one differently. So you're doing the objective aperture control over there.
Mm-hmm. Getting a little bit better.
Yeah. Go ahead. So I can see that your center of your objective aperture wobble is not at fully focused.
Okay.
So I would turn the wobbler off, get it focused, and then do it. And I think you'll have an easier time.
Yeah, I would say so. Okay. Yeah, totally.
So I can't immediately AirPlay, but so if you have like AirPlay on like your iPad or your MacBook
Yeah.
Air, you can like AirPlay this to that, and then just like set
sweet.
that wherever you
That's
want.
really nice. Cool. That looks a lot better, right?
That looks great. Yeah.
Perfect.
It's not perfect, but it's
for
not
for
the,
what we're doing.
It's not the problem with this microscope. So, more cowbell.
So true.
So it's wobbling in 3 positions on this microscope because it's using the focus DAC to do the wobbling. It's not like coupling in something else, and it's a little bit slow. But I don't mind the 3-position wobble. Like I haven't found it to be limiting. As long as you're scanning quickly enough. Even like newer Zeiss microscopes do that too, or some of them do. I think it's Zeiss, if I'm not mistaken. How we looking?
So I can probably cause that other failure mode because it was starting to get a little hairy when I was tweaking right stig.
I'm gonna go get the oscilloscope
Okay.
while you do that.
Should I try to start it?
Yeah, absolutely.
So the other failure mode on this seems to be pretty commonly triggered by the Y stigmator adjustment. Of course, when I want to try to trigger it, it's probably not going to work. But I'm going to just mess with both the stigmators until something bad happens. I'm going to kind of play with different mags too.
Okay, I have an oscilloscope. I don't have probes yet. Okay, I got probes.
It's not happening. Let's keep messing with it.
Okay, I possess an oscilloscope. I'm gonna... Okay, so... I guess we'll start kind of with the theory that this is a stigmator issue.
I can't get it to happen.
Okay.
It was just starting to happen.
Try, you could like increase your beam current, might make it more likely. No, the spot size. If it's charging, that might make it more likely.
I'm just kind of trying to drive it all over and see if it starts.
No, great call, great call.
We should just put a sample that's important to my research in here, and then it will start immediately. Oh. Maybe. That was something. No.
I think it's lens cont 2. Yeah, lens cont 2's got our
I'm gonna move this sample around a little, see if
STIG drivers on it. I think lens cont 2 is one of the I think lens cont 2 is one of the boards that's the same as 840 actually. Just
gotcha.
if you're curious. So lens cont 2 does not have the digital drivers on it. It's only got the analog part. I think the DACs for STIG are on lens IO. I think that's right. Hey, collector, right? That's collector.
I think that's our collector, yeah.
I think that's our collector issue.
Here, it'd be easier if I could look on the CRT. I could tell you for sure.
Just increase the scan speed on here, and it'll do the same thing.
I don't know if it actually is. Oh yeah, it is. That's definitely it. Yeah.
Yeah, if you increase the scan speed, you'll see it the way that you're used to.
Oh sure, that makes sense. Do you want
Okay.
to, like, tap more relays while this is acting up?
Yeah, I can also probe it with an oscilloscope.
Oh, true.
But I am doing high voltage probing of a somewhat unknown voltage, but I can measure it with my multimeter.
At least because one of our failure modes.
Yeah, no, that's great. Oh wow, we can really zoom out.
Yeah, when the computer
great.
breaks.
Yeah.
How do we get the computer back into a good state?
Stop scanning. There's something wrong on this microscope where if we're in external scan and we zoom out while the microscope's internal scan generator is in one of the interlacing scan modes, or if we put the basically if we're in external scan and we put the microscope into an interlacing scan mode, it seems like we get a computer lockup. Something weird is going on with that. That's not happened with OBI on any other 6400, but I've put it on, and it is also happening with other external scan interfaces that I've tested it with today. I basically worked it down to just a circuit of like, if I touch these two pins together, just the external scan pins, it puts it into this mode where it's like not responding correctly. Okay, let me pull up the...
See if we got any chat.
Yeah, I'm going to pull up the collector.
Spirit said, I did troubleshoot my cans high voltage power supply.
Yeah, I remember that. That was great. Collector PB, page 41. Oh, by the way, Spirit, your like zoom image stitching thing is very cool. I don't like have any Windows computers to test it on, so Sorry about that. At least not set up. But,
Yeah, that was really cool.
if you just post this thing to build, I can build it, but sorry I don't Windows that hard. God, this collector PB is also an 840 schematic. It's like all the labels, like to where it
Yeah.
goes. It's like, oh, this goes to the operational panel, and you sure about that? I don't think that's right anymore. I mean, like it does kind of go where it says, but not really.
It looks so bad when you zoom all the way in.
Yeah, a lot of the brightness changes too. Okay, so let's see if we can get it in a mode where it stops being an issue. So let's go long working distance.
Whoa, what is happening? Oh, that's the dwell time thing.
Yeah.
A long working distance? Okay.
Just with focus. We don't actually need to do it. Oh, but let's get it back. Let's get.
Yeah. Let me zoom in. There we go.
So yeah, let's go to just yeah, let's go past 60, right? On OL course. Okay, not doing it there. Okay, so let's go to 4.9 kV.
Refocus first. Whoa.
Oh, it went away for a second. And now let's do working distance.
It's weird that it's still happening.
I'm not surprised.
Below 60?
Yeah. Yeah, it's 4.9 and 60.
But now it's okay. It's kind of intermittent, just there. Or it's behaving just a little bit differently.
Okay. Multimeter time. I'm gonna start with multimeter just because that's gonna be the safest.
Okay.
Because we don't know what the voltage is doing yet. So like our oscilloscope probes are, I think, Cat 2 400 volt rated. Cat 2 350 volt on that one. What's our Regal rated? Cat 2 300. These aren't even 400 volt. Okay, so oscilloscope probing might be out for at least directly probing the output, but I got in the meter right now, I got Cat 2 1000 volt, and our meter input's also Cat 3 100. Okay. Cool.
It just stopped. Oh, it's back.
Okay. Please stay screwing up long enough for me to find out.
Please stay broken.
Yeah. So I'm going to use the inside of the other BNC because they're just connected together. So. Yeah, I can see the instability.
Oh, yeah.
Okay, let's flip the...
Why is it just draining like that? Like it just keeps going down.
I bet it'll go up at some point. So don't touch the metal box. I just realized the metal box is like not grounded because it's not bonded to the PCB.
Okay.
Do we have a potential difference across that right now? No,
Not
no potential
bad.
difference, but yeah. That's a great design choice, Joel. Why did you do that? Well, I kind of understand why they did that.
300 volt. 295.
I don't know why we weren't getting.
This camera died. I'll be right back.
Okay. So I got the multimeter in min-max right now. So I'm seeing a pretty good spread here. Okay, so I'm getting between, so min-max on my multimeter is telling me I'm getting between 290.87 and 296.9 volts. Oh, we went down to 285.18 there for a second. Okay, can we go ahead and flip it now into the stable range?
Yes.
That hopefully still exists.
Oh, it looks stable right now. But I'll flip it.
It does look more stable on this side too.
Okay, let me. Okay, now we're into the real stable mode.
Okay, so here I'm getting 213. Let me restart my. So yeah, so here we're seeing we're just dropping slowly. That's why we're hearing that. I don't quite know why we're dropping slowly. So our maximum was 212.99, and our minimum right now is 212.34, and we're not jumping around. We're just kind of going down like 0.01 volts at a time here. We're missing a cable. The digital inputs that control other relays are floating,
Really?
I think.
Is that the whole problem?
It's possible. So the cable that's actually, oh man, unless they move the signals to the other cable, I think we're missing K14.
Well, I have extra BNCs.
No, it's not the BNC. It's the it's that white one.
Oh shit.
That's the I think that's the one that actually controls the. So we're stable right now, by the way.
Yeah, I have the screen over here too, so you can actually see it a little bit. So it looks
Oh,
stable.
cool. You want to go to unstable range?
Yeah.
So we're at 211.88 here. let's show this. I just want to show this screen to stream real quick.
Oh yeah.
So this is what stability looks like. Like we are dropping slowly, but like we're not jumping, you know.
Yeah.
Okay, let's go ahead and flip to something unstable maybe. Should just put the second monitor arm on this and like throw another monitor and just like duplicate.
Honestly. Okay, we're back to the 61 range, 62.
Okay. Yeah, we got a little bit of instability, not very much.
Yeah, it's been worse.
Here. So even though we're not very much instability, we still have a lot more instability.
Yeah, it's jumping a lot.
And we can see some on the.
Just went from 290 back to
Can you mag out some?
Oh, on the scope, yeah.
Yeah. I suspect that a lot of what's going on is faster than my multimeter can really read.
Okay, we're at 100x mag now.
Yeah, keep going out.
Oh, I crashed the computer.
That's fine. Can you
I need OBI back to.
just decrease the working distance, or what's the working distance right now?
I don't know because my screen's
Okay.
gone. I gotta reset
I understand.
OBI.
So the total range I've seen while being back here is between 295.4 and 232.29.
Okay.
So that's a pretty wide range there.
I'm gonna put this into scan speed 2 so that stops happening.
Yeah, that shouldn't have any impact on
Okay.
this issue, I don't think.
Sweet. Okay. Let me get you back to Scanning. I think it's still happening. Okay, yeah, it's definitely still occurring. Here you go. What did you want me to do again?
Oh yeah, it's definitely occurring now.
What are you checking back here?
Can you bring a can you bring the schematics book?
Yeah.
Schematic book back, please.
Absolutely.
And then also, can you bring a multimeter probe that can clip?
Yes. Here's this.
Thank you. So because I can see the instability with my multimeter here, I'm just gonna go around the board a little bit and see if we can't learn some things about this. I should just put a post-it note on this page. We're gonna be here probably a few more times. Collector PB, page 41. There should be one out or something.
Yeah, I found it. It just was
Okay.
kind of tangled. Here you go.
Thank you. So this is, so we're gonna have two red probes in, but that's fine. We're just clipping this one onto ground somewhere. You know, we'll go ahead and clip it onto ground, like on this board. That's a good idea. Let's see here. Okay, we got a probe grounded. Let's see. Did we get good reading?
Trying to catch up on chat, but my phone keeps switching to 480p.
It should be up on the computer too.
Yeah. Somebody said, "What's the YouTube chat escape sequence for the remote bell sounds?" So they look at the chat.
For remote what?
For the remote bell sound, so they look at the chat.
Was that monochroma?
That was Joe Mama.
Okay, yeah, that's another computer nerd. I think monochroma has made that exact joke before too. Okay, so let's see here. If I go on the diodes, I should basically be able to see what relays are energized, I think. Yeah,
Chat
I
wants
can.
to know what the voltage rating of the nitrile gloves is.
So, okay, rating or like functional effectiveness? The functional effectiveness is actually very high. Can you grab my iPad from my backpack? I want to like start like taking. Actually, no, just grab me a piece of a Post-it. That's fine.
You sure?
I'll
get your- I'll get your
I just
iPad.
don't know if the iPad is charged.
Okay.
Cause I'm gonna start taking a lot of measurements, and I don't want to.
I'll just get you a little scratch pad.
Yeah, scratch pad would be perfect. That's a yeah. So per the schematic, I don't see exactly how this thing's working without K14. Being connected, so we do still have that missing cable thing. I don't understand how this thing was working without K14 here.
Here you go.
Yeah, I really don't understand how this thing is working without K14 here, but okay, so okay, so we are in the noise mode right now, right?
Yes, we are at 71 on course.
I have 11 relays. Huh, where's the coil for 11? Because there is relay 11 right there. But where's the coil? 1, 2, 3, 4, 5, 6, 7, 8. There's the coil for 11. Okay, so we're in the noise mode. We're gonna go, basically I can go on the diodes for the relays, and that's gonna tell me if the relay's energized or not. So I can record if you want to just write. So this is
Sure.
our relay number, and we're in noise mode, so we're gonna be recording high or low for all
Okay.
these, and we're gonna be doing, so you can just do H and L.
Okay. Noise and what's the second word?
Noise and none, or no noise. That's what I came up with. Okay, so are the diodes numbered with the coils? So 1 is 1, 2 is 2, 3 is 3, 4, 5, 6, 7, 8, 9, 10. Oh, the diode numbers match the relay numbers.
Amazing.
Wild. Okay, so 1 is low. So 1's low.
L,
L. 2 is high.
H,
3 is high. 4 is high. 5 is high. 6 is high. 7 is high. 8 is high. 9 is low. 10 is high. 11 is high.
So 1 and 9 are low. Everything else is high.
1 and what?
1 and 9.
So 9 and 1. That makes sense. It makes a lot of sense, actually. I think in this case, low is energized. Yeah, low is energized.
Yeah, that makes sense.
Yeah, so relay 1 is the top of the voltage divider, so that's the highest voltage setting right now. And then relay 9 is what connects K5 and K4 to the positive setting. So let's go ahead and get out of our noise now.
Okay. Give me a minute.
No problem. If we had the serial hooked up, we could just do the memory, and we knew what was going on with the memory rate commands.
So
It's gonna be so much fun to make a good application for this microscope.
I know. Okay, you want me to go back to the stable mode?
Yep.
Okay, you
Okay,
should.
we're stable. Yep. Okay, and then you're ready to record?
Yes.
Okay, so 1 is high.
Okay.
2 is low. 3 is high. 4 is high. 5 is high. 6 is high. 7 is high. 8 is high. 9 is low. 10 is high. 11 is high.
All right.
So 2 and 9 are low?
Correct.
Okay, so that's basically dropped us down just one rung on the voltage chain,
Okay.
or the voltage divider. just sheerly out of curiosity, can you? Or actually, let's make some other observations while we're here.
Okay.
So we're in stability. We're going to go ahead and probe our output here. So there's our output right now. So that's 212.1715. So that's pretty stable. I could put it into min max, but it's just going to slow it it's just going to show it kind of slowly changing just a little bit. We're going to take that out. Oh no, we're going to leave that in. We're going to leave that in. And we're going to now, let's go ahead and flip to our unstable mode, please. So now we're at 290 and we can see our instability. And can you increase contrast some?
Is that good?
Yeah.
I can't see, so you gotta get.
Yep, that's good.
Okay.
Can you mag out? Are we scan speed 2?
Yeah. So we won't crash.
Cool.
We're all the way at mag 15.
Yeah. It's not as unstable as it was before. I'm just gonna poke at 1 here, see if we can do something with it. I got it to do it by touching 1.
Yeah. I'm watching on the stream right now.
What?
Oh, I see that. Yeah. Yep, I'm seeing that.
And it's kind of doing it on its own too.
Spirit said bad resistor. Those are carbon composition.
Oh, good thing to check. So if it were a bad, no, if it were, well, okay, so Spirit, here's the thing though, that is a good idea, but what I'm looking at right now is, so that's 1, right, RY1 there. So this is what's closed when we're unstable, and this is what's closed when we're stable. So if we did have a bad resistor like R1 or something, it's in the voltage divider chain, right? So you'd see it at any of the relay settings, is what I'm thinking. And then if so 2 is stable, 1's unstable. It seems pretty deterministic when you flip between the 2. Yeah, I don't think that could be a resistor. Okay, now we're really unstable. Let's measure what we got. So here's what it's looking like when we are pretty unstable. Let's do our min-max. Oh, it got better. Hi.
There we go.
So we're actually pretty stable right now, relatively speaking.
Yeah, it looks better than it did.
Yeah. Okay. So actually what we should be able to do then is the voltage on the resistor chain, so like the voltage on R1, that should be absolutely fine. So the issue should basically be across relay 1. So there's just measuring the voltage here. Let's restart. I mean, I guess it's possible we still have some instability there. So that's 294 on that side of R1. That's... oh.
Oh. Instability. Oh, that was your owing for. I'm like 10 seconds behind.
Okay, this is interesting. The voltage on the other side. So relay. So relay 1 is 1 is low right now. 2 is high. So if we measure our voltage on the high side of R1, we're a little bit unstable. But if we measure on the low side of R1, we are very unstable.
Oh, yeah.
And I'm just talking about what I'm seeing on the multimeter. So it's like across R1, we have like a kind of a difference of what's going on here, which makes me wonder.
No, the relays are not socketed, Gene, unfortunately.
And then there is some instability there too, but it's like, it seems like, I think it might actually be R2 is not opening all the way.
Oh, really?
And I think it's R2 that might be loading. So let's, what we're going to do now is we're going to probe across the resistors. And then that should actually show us like where we have a voltage drop across a resistor. And that, I think, will be a really good indication of, that would be a good indication of what is up. And we're high voltage probing, so we're going to use one hand for it, so we can't electrocute ourselves in a problematic way. So voltage across R1, and I just want to make sure I don't short this whole thing to the case. I do have a I think I have a 1 mega ohm something between where I'm at right now. Let me verify that. R9. Yeah, we have at least a 1 mega ohm resistor. So our fault, I'm not evaluating this from like, oh, I have 1 mega ohm, I'm safe. I'm like, oh, I have 1 mega ohm, I can't destroy the power supply doing this.
Sure.
1 mega ohm is nicer to have for me. I'm glad I do. Okay, so we are unstable right now. Are we focused? Are we glare free? We're glare free enough.
Yeah, it looks good on my screen.
Okay, so we got like,
There you go.
a 100 volts across R1. Oh, I don't want range. Let me put it
Whoa,
auto
the
range.
instability went away.
Why won't you go back into auto?
As soon as you bridged those, the instability kind of chilled out.
Really?
Yeah.
My multimeter does have a 100 mega ohm impedance, or sorry, what is it? Is it 10 meg input?
Literally,
on
yeah,
the
as soon as you pulled those probes off, the instability came back.
Okay,
The millisecond that you did it.
interesting. The collector voltage also probably changed. I am probably loading the circuit by probing it.
Sure.
Can you stand up for a second? I've been sitting down here
Yeah, I know.
for a sec.
It's a cramped little area.
Yep, sure is.
I gotta leave in about 15 minutes, unfortunately. I'll be back later tonight, though, just probably not for many hours.
Sounds good.
Or as in, I won't be staying for many hours, so. But I'll see you later tonight, for sure.
Okay. Cool. I am just gonna stand up until I no longer have leg falling asleep.
It's a good idea. How's everybody in the chat doing?
How
many
is
people-
everybody in the chat doing? We enjoying this chat?
Spirit said 10 meg, but are you actually in 10 meg mode? Because not because it's not 10 meg in all modes, if I remember correctly.
OBI fell asleep.
Oh,
Yeah, I think that I'm pretty sure we are 10 meg on every voltage mode on this one. I think maybe not millivolts, but oh, it's going away on its own. I didn't touch it.
that does happen too.
Can you flip in and out of stable range?
Yeah. We were at 67 there actually, and
Okay, it's doing it now again.
okay.
Can you go out some? Back in. Oh, you see that brightness change when it does it?
Let me watch on the stream. Oh yeah, I did see that. I'm at 56 now. So I go back up to like
Yep.
62. I hear the relay click when I pass past 60.
Yeah. I don't think you're hearing the relay click. I think you're hearing like an arc.
Really?
I think that like. I think that's. I think we have a damaged contact in relay too, but I haven't proven it yet. This is
Okay.
just.
Here, I'll make it happen again. Listen real close.
Yeah. Well, I'm not going to put my head next to the high
Well,
voltage
sure,
box,
sure.
But I will get slightly closer.
All right, I'm gonna bring it up again.
Okay. Yeah, that one just doesn't sound as healthy as the others.
I'll be right back. I'm gonna go look and see if I have another collector board.
Okay. What I think we can do is you basically don't use a bunch of your relays anyways.
Okay.
So we can put it somewhere else, maybe.
Okay. Yeah, let me go double check because I
Oh, can you put us in the unstable mode?
Yeah, that's above 60.
I think so. Yep, that's unstable.
There we go. All right, I'll be right back. I got my mic off. I'm gonna go check.
Okay. What is let me check what the resistance of R1, R2, R3 is. Oh, they're kind of different. Okay, so R1 and R2 are 1 mega ohms. R3, R4, R8 are 200K. R5, R6 are 150. R7 is 100. And then R9 is another 1 mega ohm, but it's a different part number for that 1 mega ohm. Interesting. Okay, so that's interesting. We are unstable. Let us bridge the 1 mega ohm resistor with a 10 mega ohm resistor. Oh, we're manual range. I don't know why range went to. Why? Oh, you have to hold it to get back to auto range, right? Okay, so that's unstable. Now, if I do it to R2, does it do the same thing? So if I go across R2, that does not cause the instability to go away. I think relay 2 is not fully open circuit. I think that because relay 2 is not going full open circuit, we are getting it's like loading down. It's pulling down the output here is my current working theory.
No luck.
What?
No luck.
Okay. So So when I bridged R2 the way that I bridged R1 with the probes,
Yeah.
noise did not go away.
Interesting. So
Also, I think I didn't actually pay attention to this. I should. Was it stable when I did that? There's a little bit of instability. There's like, I'm seeing like 3 volts. Let's min-max that. So 80.68 down to 74.55. Is there voltage difference across that? 80.68, 74.37. Cool. Now let's do R1. Oh, weird. R1's like more stable actually. Just by a little bit. But it goes away when I do that. Okay, does it go away if I, does it get darker when I do it? Maybe it gets darker for some reason. No, it does not get darker. Okay. So if the noise is going away when I put another resistor over it.
I accidentally opened Safari on that screen. Can you tell me where my mouse is? I'll just flip it back around real quick.
Yeah.
Sorry.
You could just Command Tab.
So true.
Okay. Oh, yeah, you gotta fix it because OBI is like doing weird. Okay. I have an idea.
Okay.
Can you get the knobs around this side?
Yeah. Here, let me give you this back.
Honestly, that's fine.
Okay. Well, I'm gonna make it even better.
Okay.
There you go.
Thank you.
You want the knobs?
I want the knobs.
All right. I'm gonna pull this cable out a little bit more, I guess. Hopefully, it's not caught on anything.
Yeah, it's looking okay so far. If you give me 2 more seconds, I can see it better. Yeah, you still look okay. Yeah, you look good still. Still are good.
That's about as far as it'll go.
Kind of pull up.
Oh, I see.
Okay, stop. That's okay. We could get more out, but that's probably plenty.
Here you go.
Got him.
Sweet.
Look at that.
Lovely.
Ooh, now it's just getting darker and lighter. You see that? It was like,
Yeah, it's done that a couple times today.
that's cool.
Okay. We have some chat responses.
Yeah, what's chat saying?
Well, Gene said it's like, can you open the relay to burnish the
Burnish, yeah, burnish the contacts. That's exactly what I'm thinking about doing, Gene. I do not know if I can open the relay. Burnishing the contacts is what I am thinking of doing.
As a non-electrical engineer, what is burnishing the contacts?
Burnishing the contacts is you could think of it like precision. This isn't what's happening, but precision sanding. It's basically
Okay.
cleaning the contacts.
Sure.
But you're trying to not really take material away as much as you're trying to just like remove non-metal and then move metal around to make the metal in like a good state.
Okay.
Okay. So my working theory is that the problem is with R2 and not R1, and that the problem is that relay 2 is loading down the circuit even when it's open. ways we can address that. We could remove R2, or we would probably like replace R2 with something else that like never gets used, and then just like some mode that I don't think we can ever like actually get into. 'Cause, like I don't think like most of this isn't like used actually most of the time.
I don't know when this was said, but Spirit said do some poking and prodding with a resistor, and I expect something to happen. But yeah, relay is probably the next problem. And then Joe Mama said, could ADCs and DEX be functions of OBI be done fully in FPGA to lower component count?
Could what?
Could ADCs and DAX functions of OBI be done fully in FGPA to low?
There are some really expensive FPGAs that have like DAX and ADCs in them. A hybrid analog digital process like that is not the least expensive thing. The DAX that like there are some like RF stuff that's like kind of designed for this, like RF socks, RF systems on a chip. That would do this. I think somebody, and the reason I know about those is somebody in the Discord has one, is building something with it. But as far as I can tell, those are like pretty pricey. And then mixing digital and analog, it gives you a lot less control as well.
And then Gene asked if we inspected the solder joints. Yeah, we didn't see any cracked solder
that was the
joints.
first thing we did.
Spirit said maybe it's welded. How about as per Mythbusters, a meaty whack?
I did whack them all earlier, but I do think that I think there's a good chance it's welded too.
Yeah.
Here's so on the low side of R2, which I think that's the lower side. That might be the higher side of R2 actually. I don't know. Have to look closer at the circuit board.
That instability is really weird right now. It was flashing in and out, and now it's kind of just stopped. It's darker though. The image was brighter a second ago.
So I think this is like it's just like conducting the whole time right now, basically.
Gotcha.
Okay, so on the lower side of R2, I'm getting a pretty wide range actually. Yeah, I'm getting a really quite the range there.
No kidding.
So that's measuring between my output and the low side of R2. So here, let me flip my probes around because I put my ground in the output. Oh, no, actually this makes sense. This actually does make sense because this is lower potential difference with respect to the output. Okay, so let's go lower side of R1. The auto range is freaking out. Okay, I need a manual range. Okay, so now we're manual range. So now this is the minimum and maximum voltage drop we're seeing across functionally across R1, and there is some other resistors in this chain, but okay, so we're seeing between negative 26.1 and negative 80.
Spirit said I take the resistor thing back. This absolutely smells like a no wetting current fault.
Oh yeah, no wetting current is a well. Okay, but it seems like R2 is loading down when open. So if this were a no wetting current fault, we would expect the issue to be with R1.
You are correct, Tea Cakes.
Well, I mean, maybe there's field emission happening inside here. Who knows? That's kind of a joke, but also kind of not. There could be something like that. Okay, so now what's our voltage differential here? So minus 50 to minus 190. So across R2, we're seeing a real big swing. So that's like 144 volt difference.
That's pretty big.
R3, a lot more stable. Oh, our image got stable too, though. Let me flip it in and out. I think our image is dark right now, though. Yeah, we were dark. Now we're not dark. Let me just tap on R2 here.
Hi, Monochroma.
Hey, Monochroma joined the chat. Good to have you. Oh. I just barely touched R2.
I see that. Whoa. Oh, so we'll just have you stay back there and touch it 24/7, actually. That should fix all this right up.
So then if I close R2,
I gotta leave in 1 minute. It's very
Okay.
sad.
well, I'll see you again later tonight.
Yes.
It's been great working with you in your scope.
It's been really fun. Thanks for coming out here. I'm gonna tune into the live stream as I go do my things I have to do tonight.
Oh, so I might see you in chat some?
I hope so.
Cool.
So,
Well-
I'll be here for like at least an hour, probably later in the evening. I'll send you a text.
Okay, sounds good.
I'm gonna put my mic down right here.
Can you put it in the charging case?
Yes, I will. Thank you for tuning in, everybody. I'll see you guys later.
I'll see y'all in a or I'll see you later tonight. I need to get a way of reading chat back here. Just pull it up on this computer.
Yeah, there you go.
Yeah.
I'm gonna duplicate these displays so that we can do that a little bit easier.
I can do that, right?
Okay.
Yeah. You have a good time.
Okay.
I'll talk to you later.
Bye, everybody.
Okay, chat, and then there was, well, I think the saying is then there was two, but then there was one, or maybe it's two. Maybe it's me in the microscope. Maybe that's the whole thing. I am going to actually do a little bit of infrastructure work here real quick. That's going to make our life just a little bit easier. And I'm going to add a second monitor to our monitor arm, because it is actually set up for two. And I'm going to mirror that, and that way I can just see what's going on front and back. Oh, our tripod's collapsing a little bit. Okay, second monitor arm, let's go. What is chat saying? Oh, just enough cells. Okay. Yeah, you could MCU it, but different architecture, different trade-offs. Yeah, very low current read. So, I mean, it's not low. It's kind of, because it's in the voltage divider chain, it's going across the chain. Well, there's not really I guess the other side of the chain just is like in vacuum, right? So, what did you miss, Monochroma? We determined that the instability that is not on screen right now, it kind of is on screen because it's the dark part of it. Yeah. And so we have a lot of beam instability that seems to be caused by our collector voltage. We are on the collector voltage PB right now. What we are doing on the collector voltage, so the collector voltage PB takes, so the collector voltage comes from one of the high voltage power supply boxes that drives the scintillator, the CRTs, and the collector, and I think like one other thing. that box is, so that's the power supply box. I think that thing's stable. So 400 and negative 400 volts come into the collector PB box. The collector PB box has a bunch of relays and a, real quick, do you know where the monitor arm went that we took off earlier? Is that in here still? Am I just missing it? Okay, I can just take another one off. Have a good one. Okay, so the collector PB box has a voltage divider chain, a bunch of relays. The relays select where in the voltage divider chain you are feeding the scintillator. Yeah. PMT screen currents and yeah, the PMT. Yeah, it is low. Like what I was trying to think of is like, well, I mean, it's the voltage divider, it's current like the voltage divider, but it's just, yeah, the relays are only sampling this. So, basically, I'm pretty sure at this point the issue is either going to be in relay 1 or relay 2. I don't know if it's relay 1 or relay 2. Let's see here, ways we can determine that. I mean, to me, it seems like relay 2 is loading down because we're seeing, okay, yeah, actually, if it were relay 1, if there were high contact resistance on relay 1, well, why would, so relay 2 is like, okay, so if relay 1 and relay 2 were closing, that would remove a resistor from the chain entirely, basically, because you'd be like looping around it. Okay, let me focus on the monitor arm. I'm going to be doing a lot of work back here by myself. Going to want to be able to see what's going on easier. So we're going to do 2 monitors. Okay, so let me go grab a second monitor. So I need monitor, power cable, and DisplayPort cable. No guessing, Spirit. I try to not guess. I want a smoking gun. I want to know exactly which one it is, ideally. And I don't. To say I have spare relays is a little bit generous. Like, I'm going to be taking something from something else in there, so I don't want to keep like guessing and checking. I don't want to do this twice. Doing it twice is going to be slower than figuring it out. And once you figure it out once, you can figure it out again. What I really need to do is like draw this or get it out of my head more and externalize, and that will let this go substantially faster. So, okay, let's get our second monitor set up here so that we can be watching this from the front and the back. Yeah, there is a time for just part swapping, right? You get there eventually, but I don't think I'm there yet, especially when I believe I have the tools to be able to come to an answer. Part swapping is pretty good when you're like, I don't have the necessary instrumentation to actually measure this, but in this case, I do have the instrumentation, so. Did I get a DisplayPort cable? Yeah, there's a DisplayPort cable. I just got to get it out of this arm. This arm's like got all the cable management done already. Whatever. It's not that much. And the cable's out. Yeah, that was actually a lot faster to get the cable out of there than I thought it was going to be. That's a damaged DisplayPort cable, though. That DisplayPort cable is toast. Okay, different DisplayPort cable. Look at that, chat. That is straight to the trash of that DisplayPort cable. That's never going to work again. Okay, we'll get the power cable routed, then we'll go get a DisplayPort cable, then we will get back to probing, and we will have this awesome piece of infrastructure here that will be useful anytime we're working behind the microscope, because we can just see a screen from behind the microscope. And I'll be able to read chat back here. Yeah, I'm having a lot of fun working at a site that is also like, yes, please set up lab for microscope. Also, please set up live stream for microscope. And I'm like, I can do all that. This is great. This is so much fun. Let's see here. Been meaning to play around with FPGA for a long time. Highly recommend playing around with an FPGA. I can make some recommendations if you want. Yeah, I don't believe it's a Mu Metal shield. I do believe it's a regular shield. And then just a regular metal shield. Have a good night, Spirit. Possibly see you around. Yep, cable is not good. Yeah, I wonder whose lab I'm in right now. I wonder, yeah, what's it like watching a live stream of somebody else being in your own lab? Let's see here. Okay, so I got no more DisplayPort cables right there. I know where I am going to get one from. And then that, so we got monitor power, so we do the DisplayPort, we change a few settings around. Once the settings are changed, I will have the displays mirrored properly, except it's probably gonna get weird when I plug this one in, and it's gonna change all of my displays around, including the HDMI output that I'm using currently for the HDMI capture. So I'm gonna have to like look at OBS and try to find my cursor on OBS while it's displaying that. So that's gonna be kind of weird and fun, but so we got what, 4 displays running off of my MacBook right now. That's fun. Okay, so let's get the DisplayPort plugged into the hub down here. Yeah, I'm pretty happy with the USB behavior, considering the amount of like hub stuff we have going on, and like every USB port on my Mac. Well, not every port is filled right now, I guess. I could probably run it off this hub just fine and wouldn't even notice. Maybe. Let's see here. Let's get cable routed. Okay, we're gonna do DisplayPort. Okay, that should do it. Let's put our cable management clip or cover thing in. So make sure we leave some slack coming out of that before we slot this on. I have no idea what's on stream right now, considering that I just plugged another monitor in, and that might have changed all of our settings. OBI is still on stream. Cool. Might be because this monitor is off. We will discover this momentarily. Okay, what's going to happen to everything? It'd be really cool if it just decides to mirror it. It's probably not going to just mirror it, though. Okay, it has decided to extend it. So let's do... But it didn't mess with everything else. That's actually what I'm happy about. So let's go system settings, displays. Which one did we just add? So that's an extended display. So that's a mirror for the parentheses 1 del. So we're going to set this one for also a mirror for the parentheses 1 del. And then I can get chat pulled up here too. This is going to be a little bit of chatception, I guess, because this is also streaming. Maybe I'll just get this on. I think getting this on my phone is going to be actually the easiest option for seeing chat. So what is everybody working on today? Anybody else doing microscope diagnostics? Anybody else doing SEM work or other fun projects? Oh, that's a really good point, Mama. The location next to the building column actually is a very good spot to have the microscope. We're going to get a lot less deflection in the slab. I will say, I have been, so the microscope is on a pneumatic vibration isolation platform, and maybe we'll see what performance is like with that platform not floating. But it has, it's been really good. Like I can like walk around, I can jump, and I'm like not seeing huge effects in the image. Part of that is just this particular microscope is a really, really stable platform that has a very rigid stage and is good at this type of thing. That's definitely another thing that, what? I don't care about that. That's definitely another thing that this one's got going for it, is just that it is so rigid that it's not nearly as sensitive to vibration as a lot of other things could be. Let me turn the audio off on this. Okay, cool. I got chat now. I got another monitor from the round back. Let's come up with a plan or a differential diagnosis here. So I think right now the differential diagnosis we're going for is between a relay 1. Okay, so it could be relay 1, could be relay 2, it could be anything else too, but I think it's relay 1 or relay 2. When we change the state of relay 1 and relay 2, that changes the noise. So that is like okay, we do this thing changes. And so the question is relay 1 being closed causing the noise? Or is relay 2 being open causing the noise? So how to determine that? Okay, we've got a dead iPad, at least in terms of battery. We'll get that. Oh, I have the cable right here to plug that in. Okay, that's going to be great. So we'll get that plugged in. We can make a quick drawing of this. That'll be great. Playing laser dog tag with the dog. I love dogs that chase lasers are fun. Is this a newer model than the JSM-6400? Yes-ish. The column design, the SEM column design is same kind of from the. Okay, so 733 is a microprobe, so the microprobes fall a little bit outside of like the same like Joel model line development cycles that the SEMs do. The column design is from a similar era. It's like kind of older, kind of not in some ways. The electronics though are definitely older. The electronics are based on 35C era electronics. Oh, there goes our zip tie. So 35C, yeah, you're based on kind of like a modified and upgrade version of 35C era electronics. So this has kind of got like a 2-generation newer control console. Stage is very similar. So that rigidity that this one's got, your 733 is going to also do quite well in. This one kind of was configured as a microprobe. I mean, we got all the wavelength dispersive spectrometer wings on it. That's not what we're going to really end up using this system for, or that's not I think their plan at least. It's like this would be useful for doing like polished cross sections of geological samples, and we want a really consistent trace mineral analysis and like kind of the same thing repeatedly. The wavelength dispersive spectrometers would be great for that. If we want like a general purpose, put something in, get an X-ray map of it, or get like an elemental composition map of it. Identify unknown things, and even like do kind of everything these things can do to a degree, maybe not as fast for specific applications, then like just a general purpose EDS is going to work way better than these things. We're We're probably also going to pull our optical microscope off the chamber. So the optical microscope on the chamber is a coaxial optical microscope with the electron beam. It lets you, without turning the electron beam on, focus the sample at a specific height. That's great for the wavelength dispersive spectrometers. For the wavelength dispersive spectrometers, what you do is you set your critical height for those things to be where the optical microscope is focused. So basically, you know that if the sample is in focus in the optical microscope, it's in the right spot for the X-rays to enter the wavelength dispersive spectrometers correctly. Optical microscope has got some like kind of cable sticking out on it, kind of sticks in. It's got a lot of mechanisms on it, so likely vacuum leak, honestly. It can cause interference. It reduces the quality of the magnetic shielding of the chamber. So, and we can always put it back on later. It's 4 bolts to take it on and off. So we're also going to be removing that, just to kind of strip this thing down, simplify it a little bit. It's going to make it an easier and faster tool to use for the work they want to do with it. And we can always put all this stuff back on later. So let's see here. If relay 2 is partially on, then the voltage should be jumping up and down by 1 ladder resistor worth of voltage, right? But it's not jumping 50 volts. But maybe it's so fast it's kind of PWMing it. Maybe. Okay. If I think it is like I think we've got like 50 or 60 volts, and yeah. I don't think that relay 2 is like fully conducting or not fully conducting. I think it's like partially conducting is what I think might be happening. So XRF is X-ray fluorescence. So this is this would be like a microprobe would be a wavelength dispersive, or would use like an X-ray microprobe. So this isn't at all X-ray fluorescence. The coaxial optical microscopes are generally like a microprobe wavelength dispersive spectrometer thing. Not exclusively though. Another application for them is electron beam lithography, and they're useful for electron beam lithography because you can align the sample under the beam before you expose the beam at all. And that is very useful for drawing in resist, in like photo or electron resist. So that is another, so electron beam lithography is another place you'll see the coaxial optical microscopes installed. W Stream, thank you, Cameron. Thank you for helping get it set up as well. You've been so much help. Okay, I believe we've got a charged iPad now, so let me get that thing set up here. And with this, I can just draw on a picture of the board, and I can draw on the schematics, so I can hold a lot more information in front of me, and I can get to a point of not guessing. I don't want to guess, I just want to know. Let's see here. Okay, let's get this going. Okay, this is basically the start of part 2 collector PB troubleshooting. This is, what is this? This is kind of like, it's either 2 out of 3 or 2 out of 4 of our noise sources on this microscope that we're experiencing. Our first noise source was the water chiller. That thing was just causing problems. Causing lots of problems, that water chiller. So let's go ahead and get this moved back. So the water chiller caused a persistent 60 hertz vibration, or I'm saying vibration, 60 hertz flagging in the image because it was too close to the microscope. The water chiller is like kind of right where the power supply is right now. So that was our persistent one. So we got that one taken care of because it was there all the time, always causing performance problems. Oh, I got a battery about to die. I'll just swap that one up. Noise source number 2 we're dealing with is the image effect we're seeing. That's the collector. That's kind of our next most serious noise. It's intermittent, but like it's not very intermittent. It comes up and it stays there for long periods of time. Digiren does say that it has reported to me that it does go away when they cycle high voltage completely. So got to think about why that would be the case. Because like you think that like that would do kind of the same thing as like opening and closing the relay, right? Unless it's like turning off the power supply that is driving this whole board too. Okay, I got a good battery there now. Are all our cameras pointed in a good spot? They seem to be. Yeah. M6 batteries are on my desk in the other area. Thank you very much for the info. Let me see here. I'm gonna just make sure that I've got M6 batteries charging because I'm probably gonna go through those. Oh, they are charging. Okay, cool. I got 2 fully charged, so let's swap one out to get another one charging. They're all fully charged. Okay, we got, oh, no, that one's not. Okay, cool. Glad I swapped it. We got M6 batteries for days here. Can't find the datasheet because it's discontinued. Google AI might be telling me a fib that it's read microswitch. It could, yeah, it might be read microswitch. Okay, so Digiram, you're saying you have to actually turn the high voltage off, change it back to what it was, and then turn it back on. So if you turn the high voltage off and you don't change it, it doesn't do anything. It also might be reflowing solder joints. Yeah, so the solder joints actually looked really good, like typical excellent Joel soldering. This isn't, well, I won't name specific, well, I'll name Amray because they're not around anymore. This isn't like Amray soldering. This is Joel soldering. The amazing job on the soldering. The time I saw the problem, the relay had been over microdose of lubricant and contact alloy catalyzed carbon film growth. Yeah, I could see that being the case. Had a funny situation where I was told you may have to anneal the sample quite a few times to get a reading. We had annealed it 30 times. Nice. And it was just an old solder joint. Yep. Been there with stuff like that. It's a lot of fun. Okay, so let's get to our differential diagnosis here. Okay, so we'll get the schematic picture loaded in. We'll get a picture of the board loaded in. We'll write down all of our measurements over top of it, and we'll come up with a model of what's going on and determine if it's current not flowing when it should be flowing. Well, I guess potential, because there's like barely any current flow. Or if it is, so if it's current not flowing when it should be flowing, or if it's current flowing when it should not be flowing, as I think basically are 2 options here. And then I've got the YouTube app finally reinstalled, so I can see chat from behind the microscope now, if it's actually going to be updated. Oh yeah, and then there is that bit about like the multimeter, like touching it causes it to be. I won't say it causes it to be okay. It does. It seems to lower the voltage, is what it seems to be doing, and I wouldn't describe that as like okay. I would describe that as it's not noisy, but the voltage is lower, so we're not collecting as many electrons as we would like to. Oh, I'm getting the bug in the YouTube chat still. I thought that I could get rid of that. Darn. If I just keep the stream on, I should be able to just read it. Oh, but it's doing the 480p thing. No, it's doing 360p. That's great. Advanced. 1080p 60. Come on, you can do it. Okay. I'm re-entering the diagnostic area. And this time with more tools, more instrumentation, and that should get us to a conclusion relatively quickly here. So basically my goal is, well, I got two of them. I mean, one is to fix all the issues of the noise. At a minimum, I want to have an actual diagnosis in all of this. I have at this point pretty much diagnosed it as being the collector PB, so that's great. Okay, we got good notes now. We're gonna have great notes. Okay. So let's get a picture of our schematic into the drawing here. Come on, please rotate, because I know if I do anything, it's going to rotate the second I try to actually get something done. Okay, why? There we go. Please accept. It's accepted. Come on. Did I just hear a camera change? I don't think I did. Why are you not airdropping? I'm not doing anything with any, like... I'm not doing anything with... AirPlay. It should have no. I can't. Why? Why are you failing? It should be. Okay, there we go. We got it. And then we'll also get a picture of our board. Come on. How many? How? Let's guess how many times it's going to take attempting to airdrop for it to work. Oh, it only took 2 times that time. We're doing great. Okay, let's import our drawings now, and then we can start maximally externalizing information and as efficiently as possible solve the problem. Cool. Got our drawing. I'll get chat back up. Leave the multimeter attached permanently. That is a funny suggestion. Okay. Let's see here. Let's... where are my cameras pointed? Why is it not? Oh, it's just I'm super delayed. That's why I can't see what's currently happening. It went to sleep. I have to go poke at it. Ooh, ultrasonic and RO system just showed up. Gonna have fun with that. Our relay contacts OB silver is a special metal mix commonly used. Yeah, I don't know. But Gene would know. Gene's done a lot of diagnostics on that type of stuff. Problems in sealed magnetic reed switches, input range, section of high-end oscilloscope manufacturing. Yeah, okay, not a place you want contamination. Oh, rhodinium contacts. It's been great to have you, Peter. But that was fun to manufacture. Have a good night, and hope to see you next stream. Okay, let me poke this computer, and then this iteration of the streaming setup should be complete. We can get back to it. Is OBI still happy? Yep, OBI's. Well, we are getting some scan stops. Wonder why we're getting scan stops. That probably is because the computer went to sleep. Having your server go to sleep and then wake back up, not always the easiest to get back to a good state. And so I'm doing a little bit slower scan. Maybe we can actually see kind of how it progresses. Okay. Both starting with R for relay. Nice. Okay, let's get our drawing going here. Kind of turn to face y'all chat. Okay, so question is basically, is it relay 1 or is it relay 2? So let's see here. We are in the, look at its working distance. We got to change. That's mag. Okay, so let's do 2 drawings. Let's do a drawing of this in the state where it is working. So we're gonna have, this is gonna be our this is gonna be our okay state, and this is going to be our sad state. So in our okay state, the let's just we made a lot of measurements today. They're all recorded, but they're not written down in front of me, so I don't have as easy access to them. So we're going to stop that. We're going to restart that. We're going to, we have our probe in our output. What we're actually going to want to do is probe ground. Okay, so I'm going to put, so the microscope is in the okay state right now. Okay, let's take our measurements on our okay state. What's going on here? We're going to go to, see, is relay 1 closed? So we got 4.7 volts there. And we got 0.2, 4.7. Okay, so in our okay state, we've got there it is. In our okay state, relay 2 is closed. And then I think relay 9 is also closed. Is there other one that's closed? So relay 9 is Yeah, relay 9 is also closed. And relay 9 is closed in both states. And then everything else is open as shown here. Okay, cool. In our sad state, it should be relay 1 that's closed, right? Yep. Okay, so we're in the noisy state now. Relay 1 is closed, 2 is open. Okay. Relay 1 is closed, and then nothing should have happened to relay 9, so relay 9 should still be closed. Diode 9, relay 9, yep. Relay 9 is also closed. Okay. I'm going to kind of overlay these with each other a little bit more so that we can just kind of have easier time comparing. Come on, please select. Why won't you go to the back? Let's just do a new layer. Okay, so there's our okay state, there's our sad state. So, I guess something we could do is like, what's the potential difference measuring? Can you see what I'm doing easily? Let me bring you in more here. Oh, no, that way. Doing this with a delay is fun. Okay, that should be good. Let me see if I can lock that now. Oh, that was unlocking it. Okay. This tripod like springs up, which is good for video stuff, not quite for what we're doing. Relay 9 is indeed part of the polarity changer chain. That is correct. Okay, so if our theory is that we have like some potential going across relay 2 in our sad state, then we're basically selectively oh, and the other question is, so sad is okay. Let's get some outputs. Let's take some voltage measurements here. What is the voltage output in our so we're in a good state right now, unless we're not, and it's just lying. Oh, loading down the output with the multimeter is enough to make it change quite a bit, actually. Okay, so I see instability. I'm getting like, let's reset our min maxes here. I know we did this earlier, but we're doing it now that we're like, taking notes. So we're getting like we're about 300 volts. And then let's go to our OK range. So in our OK range, we're getting 215 volts, approximately. Okay, so let me flip the screen around so I can see it, hopefully. Okay, so when relay 2 is closed, we're sampling, so our current is flowing, current's flowing through relay 9, through our variable resistor, there, and through all that. When that's our path, we're getting a low, stable voltage of 215 volts. So that's good. That works. When we are not doing good is in, I think the one we're in more frequently, which is where we have collector voltage set to maximum. We're doing that. So now here's a question. So it looks like the noise appears to be the image getting much darker than it should be. So if it's getting darker, it means the voltage is going down. Now, a challenge I'm having a measurement challenge right now, and the measurement challenge is that we got a lot of high impedance resistors here. Let's get some resistor values written down, because this is one of those circuits where like our values are indeed going to matter. We'll do our resistor values in blue today. We're going to do, okay, I need to know what R9 is. R9 is 1 meg. So we got 1 meg there. That's a 1 meg VR. R1, I'm pretty sure R1 is also 1 meg. Yep, R1 is also 1 meg. R2 is also 1 meg. We'll go ahead and do R3 too. R3, 4, and 8. 3, 4, 8 are 200K. And 8 is 200K. R5 is 150K, so is R6. R7 is 100K. R16 is only 10K. That's interesting. That's really good to know that we have only 10K there. And we'll go ahead and get VR2, R12, and R11. Okay, R11 is 750K. Just like going through this right now, I'm even questioning if it's actually the relay. Of course, it's got to be one of the relays, right? Like, but that's why I want to know before I start throwing components at it and guessing. 1.6 meg, 1.6 meg, and then VR2 is 500K ohm. And then, am I missing anything? I think I got it pretty much. And then, because I put all this on its own layer, I can select just that. Filter, active layer only, and we can duplicate that. And then, Oh, no, I don't want to move it. I want to duplicate it, which I didn't actually do. So let's select that again and then duplicate. And now I can have all of the same labels on my other one too. Okay. So we're seeing, and then it is, and then let's, or, okay, what's chat saying? So we actually have never entered a state where relays, we have yet to enter a state where relay, or anything but relays 1 and 2 are activated. I think it's pretty uncommon that relays 1 and 2 are activated. So yeah, flyback instability is a possibility. I guess to see that, we'll just go to the top of R9. Okay, what we can also do, let's, we also have the schematic for what's going on inside of the, power supply. Let's follow that back and see if we've got any other resistors there. Yeah, there is one resistor on the output of the flyback. R13 and R15, R16. Okay, what's R13? Okay, what is the unit code? That's HVOSC 06 Charlie. Yep, that's HVOSC 06 Charlie. Okay, HVOSC 06 Charlie R13 is 20k ohm. Okay, that's not a lot. Come on. Okay, so before this, we've got like, I think like 20k of impedance. So theoretically, we should, I think if we go on the high side of R9, we basically shouldn't really see our instability if our flyback is in good shape. It'll probably get loaded down a little bit. But that flyback is also, like the flyback's doing a lot of other things. Well, several other things, including one of the CRTs. And the CRT, I've never seen an issue with it. And it is a different part of the flyback. But yeah, the overcurrent theory is something that we have talked about. And I think we did something that was like kind of ruled that out. But it's recorded. It's not written down in front of me, so I don't have it to work with. So we are going to make some measurements and write down in front of me to rule that out. Okay, so let's go ground to, zoom you out so we can see what we're doing. We're gonna go ground to R9. Where? There's R8. Okay, there's R9. What side of R9 is our high side? I don't actually know. Oh, that's our high side. That's gotta be our high side. Okay, so our high side on R9 is 513 volts, 513.7 volts, and that is, yeah, 513.7, 513. That is stable. So we've got noise on screen. We are in the instability right now, and we have a stable voltage on R9. So that tells me that tells me that this issue does not it'd have to be something really weird that I do not understand for this issue to be extending outside of, the, outside of this box. Power coming in seems stable and smooth. So we got 513.7 volts there. So let's look at the other side of R9. That might be interesting. So now we are in, okay, 10 mega ohms of impedance in the circuit. We are now in high impedance territory. Let me look up on my Flu, because I keep on, it's 10 mega ohms, right? It's got to be 10 meg. So the Flu 289 input impedance. Flu 289 input impedance. Sure, we'll try the search assistant, but I'm still going to end up wanting to find it on my own. Just give me a link, because I don't trust you for something this critical. Specifications. Okay, this is a... This website does not work. And it has me trapped. Why, what? How did you generate that much search history that quickly? I am so confused. What is going on? We're gonna go 10 mega ohms. So, high impedance circuits, you always got to think about like what probing it alone is going to do. Oh, we lost that screen. Okay, already? That's annoying. Let me go jiggle a mouse and maybe change a sleep timer. Okay, so 10 meg. System settings. Turn off the display, never. Turn off the display when on power adapter. Oh, no, we do want to turn the display off when we're on battery. On power adapter though, never. Start screensaver, never. Okay. We shall not screensaver anymore. Okay, let's do this. What are y'all saying, chat? Any way to measure the current going out to the grid to find a leak? Yeah, maybe. Yeah, you know, that's a good point. Like, we are seeing this issue once the voltage is higher, right? So, like, maybe that's causing a leak. Maybe we're getting corona somewhere. That's a very interesting theory. Okay, I'll tell you what we can do. We can unplug the collector, actually. Yeah, we can unplug the collector. And then if we unplug the collector, I won't be able to see the instability on screen anymore, but I should still be able to measure it. Yeah, I should still be able to measure it. Okay, so yeah, let's see if we can isolate. So we've isolated, this is a good troubleshooting step that we didn't take earlier. We isolated going to this board, now let's isolate going out of this board. So we are going to take our collector and we are going to unplug it here. Okay, so collector's unplugged. And it actually got stable. And you want to know what's really cool? And this actually shows just how, this is wild. This shows just how little current the collector's actually using. With the collector unplugged, just the capacitance is like enough to keep it, we're still at potential. Like the collector hasn't been discharged yet. I can discharge the collector through my multimeter, through a 10 meg resistor. So there's like, on that pin right now, the voltage is still there. It's just acting as a capacitor, and the capacitor is enough to keep our collector super stable, which I always think is like really cool that when you unplug the collector, it just stays collecting electrons. Okay, so multimeter is grounded. We're going to touch the center pin now. As soon as I touch the center pin, we discharged it, and we lost our image because we don't have collector voltage anymore. So that was literally just the capacitance of the cable holding the voltage, acting as the collector. So if we take our collector and we plug her back in, we're back. We're noisy, but we're back. So we'll unplug that, and yeah, it's stable now. Isn't that fun? I just think that's so cool. Okay, so now let's see if we still have the symptoms of our instability now that we have the collector pulled. So here's another thing. I feel like, so another reason I'm trying to be really thorough diagnosing this here, this is an intermittent issue. Once it starts, it doesn't stop, but it has taken hours for it to show up before. So I pull everything out, I bench test it, I don't find an issue, and then a day later it comes back. It's like with these intermittent problems, when I have it in front of me and I can probe it and I can measure it and I can figure things out about it, I'm gonna take every chance I can to do that, because proving it out after it's like, well, it's like, is 2 hours enough? Is 10 hours enough? Like how long do I have to run this thing to know for sure that I actually found and fixed the issue? So intermittent issues, I think, take a different component. Throwing components at intermittent issues can be very time and cost, can cost a lot of money and time. Okay, what's our next plan here? And our next plan is we are going to probe our output. Oh, got that tangled in the camera HDMI. Okay, let's probe our output. 302 decreasing. Still decreasing. Not seeing a huge amount of instability though. 297. So that's our output with respect to ground, with the thing unplugged. Yeah, it is kind of like the electron mirror thing. It's still going too. I think it's cool. 297, 296. Okay, so now I'm going to switch this over to here. Let's see what we get when we plug our collector back in. Oh, we don't really have the instability right now. Okay. We do when I stop probing it. Okay, so our circuit is too high of so. Well, let's just draw this. Let's draw this. When we where's my pencil? Well, it's not really a pencil. It's there's stylus. There's it is. Okay, so in the sad state, when we put a 10 mega ohm load in the form of our multimeter from, so when I go from here, and then we have 10 meg resistor, and I go to ground, we don't get noise anymore. So that's, well, you could say there's 3 megs there. That's a voltage divider chain. How much resistance is in this voltage divider chain? Okay, so 1 meg, 2 megs, so that's 400K. That's 300K, so add those together. That's 700K, 800K, another 200K. So this is all a meg. So this is a 3 meg divider here. So we got 3 megs there, kind of 1 meg-ish there. We got 500 volts coming in. We got 300 volts coming out. This all tracks. This all makes sense. What doesn't make sense is why when we load it down, the noise goes away. Okay. Okay, so now we're in fault state. We got noise. Okay, so let's go back to methods that actually let us measure things here. Things that didn't affect the circuit very much. So this actually worked out pretty well. When we had our probes running across our circuit, so we put one in our output, and we put one, let's go to the R9, R1 node. So top side of R1. Well, that's basically just measuring the same node. There's only 10K between that. So we are unstable, touching that. Made it brighter. No, touching that resolves the noise. Touching that resolves the noise? Touching that does not resolve the noise. Why is adding... Is it because I'm pushing on it? Huh. I did not expect that. Oh, I resolved it in the low state. Interesting. I don't get like a potential difference there. So weird. Okay, and then when I go on the low side of R1, okay, so low side of R1, okay, this is cool. Okay, so lower side of R1, I can see the noise on my meter. I can see the noise in the image. And let's see if it goes away when I flip it. Let's see if the noise goes away when I flip it. Oh, here we go. So it was going between like, it was really dipping there for a little bit. We were like down in the like, yeah, there we go. We went into like -20. So that's actually, okay, so that's when we go to like our fully dark state, we get to that. Okay, so in our good state, we have between here and between here, we have no potential difference. Is voltage turning the camera on and off? Do I have a camera going on and off? I don't think so. But I haven't seen a camera go on and off yet. I might have one going on and off though. Oh. No, I see what you're saying now. Okay, so we're in our good state. Let's go to our not good state. Okay, we are in our noisy state. So now we got -75. We'll go ahead and min-max this. Okay, so we've seen... Is that real? Does it actually say as low as 0.327? That's interesting. So we got like between we'll say between 27 and 96 volts of difference between these two nodes now. Okay, so this is a thing that we can see even when I think so this isn't loading circuit enough. Putting this stuff, putting the probes on it in this way does not immediately make our noise go away. In fact, if we can see the noise in the multimeter. Okay, so we've got a way, even with the impedance of our multimeter, to measure the noise. Okay, that's great. Let's see what happens to our measurement when we remove our collector BNC. Let's see if we still got the instability. Okay, it's reading -27 right now. Flick it in, still -27, which we did see sometimes where it would get dark. So this has stayed at minus 27 and it has stayed stable the entire time I've been measuring it with the collector unplugged. I don't see the noise. So the problem with an oscilloscope is I need a transimpedance amplifier because of how the input 1 meg input impedance would be challenging in this environment. There we go. Okay. Okay, I can see it. And then it went to 27. Okay, so sometimes it's stable at 27. Sometimes it's, sometimes we have problems. Okay, but we were able to recreate the noise without K1, sorry, not K1, without K5 plugged in. So that tells us that this issue exists inside this board without the, we'll say, assistance of the scintillator, or sorry, the collector being actually attached. Okay, so that I think helps indicate that we do indeed have an actual problem on this board. Okay, cool. I'm glad that we have like found something that was like, okay, you can see this. You can still see the noise even when collector is unplugged. Very good. Okay, so, man, I do just want to like, it's very tempting to just like start pulling components and be like, does that fix it or not? But I won't know because it's just taken such a long time sometimes for this thing to actually start making problems. Okay, so let's look what would happen if let's look at our sad state. What's going to happen if relay 2 is conducting? We're just going to bypass the 1 mega ohm. And if we bypass the 1 mega ohm, then I think the reason it's so okay. You might think I think I might have to do the math on this. You might think that if you bypass the 1 mega ohm, then the node moves closer in resistance to the top of the chain, right? But then instead of becoming like a 2 meg, 3 meg voltage divider, it becomes a 2 meg voltage divider. So that actually, like, that would also drop your voltage. And so yeah, that would drop your voltage actually if you bypassed the 1 meg. And we kind of see some evidence of that, right? So when it's the darkest, the difference between the K5 node and the R1, R2 node is the lowest, as seemingly what I have seen. So let's do this. Let's go into the good state. So in the good state, if I measure across R1, which is putting a 10 mega ohm resistor across a 1 mega ohm resistor, what's going to happen? Very, very curious to know. So we got minus 116 there. So that's measuring across that. And this is in the good state, right? Ooh, I think that was really telling right there. So in the good state, we're getting 116.5. In the sad state, we're getting 27.5. Oh, up to 96, down 27. Okay. Which is basically what we were getting before. Which is like, we're actually like doing basically the same measurement as before. So we are seeing that when the noise is happening, the voltage across R1 is dropping, which seems to, again, be consistent with the problem. So yeah, that seems to be consistent with we're conducting through R2, through relay 2. I think the voltage across R1 is very telling here. Yeah, that seems like a really solid explanation of what's going on. Sherlock Ohms. Nice. Have a good time. Yeah, so I even in the unstable states, I've measured the voltage coming from the flyback, and it's been stable. We can verify that real quick. It's also not nearly as sensitive to impedance, so that's cool. And it's pretty easy to measure. Yeah, okay, I am seeing like a 1 volt difference here. Interesting. Am I on the right side of that? Yeah, I'm pretty sure I am. I would expect to see a little bit of a difference because we are like, I think, changing the load slightly. But I think we're changing the load by almost a mega ohm is the working theory. So I think that would cause what we are seeing here. I'm pretty happy with the. Come on, I didn't want to type. I just want to go up. Okay. Let's see here. I think the difference in resistance across R1 is like very telling. Ooh, welcome to the stream, Maria. We are debugging something quite fun. Good to have you here. Hope you're feeling good. We are debugging this board. This is the collector power supply. So collector is the thing that attracts all the electrons in the chamber. It's got our input power supply rails there on those cables on the left, our output on the right. And then it has a voltage divider with all these resistors here. The relays change where in the voltage divider chain we are taking our voltage, and that changes the voltage going out to the collector. We determined that a lot of the noise we were seeing on the microscope, and I can, it's the noise you're seeing like in the image right now, that noise is from the collector doing very weird things. Namely, the voltage on it seems to be dropping. So we are figuring out why is the collector voltage dropping. Working theory is it's relay 2. So here's what we're looking at on our iPad here. So in our OK state, well, first off, these are all of our relays, right? 1 through 8. Those are the values of the resistors. So as we go through that relay chain, we have like 500 volts at the start there, and we have a ground there. So there's a potential gradient across all that, and we can flip in a resistor to choose what voltage we want to be outputting to K5 or K4 there. So when we have it configured for like a 215 volt output, everything's stable, everything's fine, everything's happy, and that's with relay 2 closed like that. But when we configure with relay 1 closed for like a 300-ish volt output, that's where we start to get our instability like you're seeing right now. And most of the time the microscope's in that 300 volt state. It's not in that 200 something volt state very frequently. So we are figuring out what's going on. Working theory right now, and I think we basically have just verified this, is that we've got that relay 2 is conducting when relay 2 shouldn't be conducting. Like, so we open up relay 2 and we get bad things going on. And what's convinced me of that, and I really am curious what chat thinks about this, when we are in, okay, so the current output, the current load, like the amount of load being applied to, or being, amount of load from K5 is minimal, absolutely minimal. See, amount of load from K5, very, very low, very low. When we are connected through relay 2, we get 116 volts of potential across relay 1 there. When we are in this state, again, very minimal load in our output, we get a lower voltage across R1. And I think that that is happening because we are basically getting some amount of electricity flowing through relay 2, even though relay 2 is open. And that's why we're getting between 27 and 95 volts across R1 instead of what we should be getting, which is like 116 or something. So I think that basically tells the story of what's going on here. And I think that I also suspect, like, Yeah, I can hear a relay too. You know, I should get like an insulating tube and then stick it on that relay and see if I'm only hearing, see if I only hear relay 2 click or I hear relay 1. I could also try to manually control these. And DigiRen is out for a bit, and we'll be back later tonight for a bit longer. Okay. So what do we think, chat? What do we think about our voltage drop across R1 being our telltale here that we do indeed have a relay 2 issue? I just don't want to have to debug this again. I am like flipping the working distance a little bit, which is what's causing the mix-up to trigger the relay flip. So in bad state, let's just touch relay 2, see what happens. What do we think, chat? I think I'm convinced on relay 2 here. So I want to see it be stable for a little bit in the bad state, which I can induce the bad state. I can induce stability in the bad state, or the sad state, by probing. Come on, randomly go into one of those really useful states for me to see what's happening, please. Well, Gene thinks we're on the right path here too. Okay. So then the question is, what do we do? What do we do about it? We don't really use the other relays very often, if ever. Okay. I think we're gonna borrow relay. It's actually not just output brightness. It's also the beam like shakes a bunch, which is kind of worse actually. I think that we are going to borrow R8 and just move R8 to R2. How do you feel about that, chat? R8 to R2? Shall we? And this problem has changed behaviors even while we're probing it so many times. That is another thing that has been frustrating, is that we're not probing something steady state, we're probing something that is dynamic. I had a Megger with me. If I had a Megger, I could just test R2. Okay, last thing I'm gonna try, I'm just gonna, I have tubing right here for this actually. This will work great. Sure it doesn't have any water in it still, which I don't think it does. Okay, cool. Let me just get a link to this tube. Okay, I'm just gonna cut it off that barb. Okay, we have our listening device. And we can listen to it, and we can see if R2 sounds as different as I think it sounds from R1. Because it makes a different sound, like, you think it would like basically make the same sound, like clicking in and out, because you simultaneously have like R1. Did we lose this camera? What's going on with this camera? Did we lose two cameras? Huh. Oh, that one just has a screen off. Okay. Because you have R1 and R2 are clicking at the same time, right? So if R1 and R2 are clicking at the same time, and making the same sound, it should make like the same sound going in and out. It doesn't. It's different. Okay, yeah, I can hear a difference. This is interesting. What is this difference telling me? Let me see if I can put something in my left ear so I can't hear it out that ear, because I can hear it through like both ears. Let's figure out what the difference we're hearing is. So a lot of times with relays, you only hear them click close, because when they click close, well, sorry. A lot of times with relays, you only hear them click open, because when they click open, there's nothing to dampen the reed from like vibrating. Ergonomics on this are rough. Let me see what I can do to actually be able to reach this and listen to it. Did I hit something? Okay, I think I know what's going on. That was just me flipping external, internal input right there. What's my computer doing? Oh, microscope's in a bad state. I can't get it out of fine focus. That's a new problem. What's going on there? Okay. So it's hard to see, but the fine focus is like stuck in. That's unfortunate. Let's just pop that out for a sec. Mag works. Fine focus kind of works. What are we doing, microscope? Okay, fine focus doesn't work. Cool. I think we're gonna go ahead and reboot our console here. Let's do some soldering. Let's figure this out. So we're gonna go. If I can do a computer reset, I can listen to it. But what it's basically hearing is, I can hear one, I can hear the other. They do not sound the same at all. I can hear them both opening, so that's good. But the reeds do not sound identical. So, okay, let's make a plan here. Where are we gonna solder? What are we gonna solder with? We got a soldering iron. We got a hot air station. Do we have a desoldering tool? Let's find out if we got a desoldering tool. I'm gonna go OPE's off. Okay, so OPE off. We're gonna give it things a second to discharge, and let's get set up for some soldering. Yeah, I'm pretty convinced by the voltage drop across R1 changing so substantially. That is, I don't know of a better way of explaining that. I was wondering if the relay, so what my thought was maybe R2 was audible when it was opening and closing, and that R1 was not audible at all. And if that was the case, that would really clearly point to R2 being like doing something. That would be weird if only one of them could be heard, right? But that was not the case. Okay, so to get this out, we got to do some stuff. Namely, we got to get these disconnected. I want to bring this board all the way out. So let's pop that open. Let's take these out. So these are going to have to come all the way out of the high voltage power supply box that they attach to. This is going to be easier to do if I just pull off this panel too. Okay, got that. Okay, let's do some cable disconnection. Fortunately, these are pretty easy to pull. You know, we can actually check the, or we should be able, yeah, we can check the impedance now between the two sides of this because we got it isolated enough to do that. So let's check the impedance from that node to that node. Okay, that's saying 1.2 meg. Why? That makes sense. That should be about 1.2 meg. Let's go between K5, which is the output, between K5 and that node. Okay, let's do that. Okay, so I'm not getting anything. Now, this is not a this isn't high voltage probe, or this isn't high voltage resistance checking. This is like using a couple of volts, but I am measuring, at a minimum, we're not getting anything below 500 meg, so that's good. Got 1 meg there, got 2 meg there, good. Nothing to the ground shield in that case. Well, actually, there is another relay there. So we actually want to be on, because we're assuming relay 9 is good. So if we're testing from K5 to R2, we wouldn't actually see anything. So we need to, so relay 9, I don't think I can get to anything on relay 9 that would help us here. So we'll have to probe this from the back once we get this PCB pulled out. Okay, we got our circuit board here. Let's get this on a bench and let's get a relay pulled out. And then we also have to decide what relay we're going to kind of sacrifice to make this repair with, because I don't have the specific Japanese relay with me. And we checked our supply of spares with this microscope, and we also don't have this. I think we're going to use the microscope bench as our soldering bench. That's going to be our best bet here. So let's get the cameras moved over. Oh, it was good to have you by, Maria. I'll excited to share what I find. And looking forward to having you back here later tonight, Digiran. Let's see here. Let's flip to this one. Let's kind of go top down more. And then I'm going to retrieve our other camera. Yeah, if this issue wasn't so intermittent, I definitely would have gone straight to just swapping this a lot sooner. It's just because of how long it takes to find out if we were correct or not that I was trying to be this kind of certain about it. Okay, I need a new battery for this one. It says I have half a battery left, but it also said it was dying earlier. So we're just going to go ahead and change the battery because I don't trust it. It's also... Okay, I got another one fully charged, but I left it behind the microscope. But yeah, I still can't come up with any other explanation for this that matches our symptoms here. I'm hopeful that we're going to open up the relay, or the relay is going to be able to be opened up, and we're going to look at it, and we're going to be like, yep, that definitely looks like a problem. That would be great. That'd be really good verification that we got this one correct. Okay. Got our other camera up. Oh, I need the tripod plate. Where's the tripod plate? Where's the tripod plate? Did I set it down by the batteries? I think I set it down by the batteries. And I'm pretty confident we can open the relay up in some way. I mean, am I confident we can open the relay up and then put it back together and use it again? No. Am I confident that we can open it up at least once? Yes. So to go from 116, to go from 116 volts at a drop across this, down to 25 volts a drop across this, that means that you're seeing less than a mega ohm. You're seeing a lot less than a mega ohm, right? Because it's a mega ohm resistor. So if you added a mega ohm in parallel, you'd get, you'd drop half the voltage. But if we're getting more than half the voltage dropping, that means we're getting less than half a mega ohm of resistance across this relay contact. And I'm hopeful that half a mega ohm across a relay contact is visible, you know? Like that is a visibly bad enough to just see the problem type deal. Okay, let's get the screwdriver we're gonna need. Cool, that should be all the tools I need from back here, I think. We'll go ahead and plug this in so it's charging. Okay, I think that's everything from back here. Let's go ahead and pop this out. I'm kind of hopeful I'm going to be able to like take the relay case off while it's still attached to the PCB. In fact, I am going to try that because if I can do that, if the relay case comes off while we're still attached to the PCB, and we're just like, oh, look at that like carbon contamination, it's very clear that that's the issue. Let's see if we can just clean that off. Then we're going to be able to repair this relay without soldering, which would be great if we could do the repair without having to take the relay all the way out. I don't mind soldering at all. You know, we have to, if we're going to use a new relay, we also have to desolder that one. Okay, interesting data point, Gene, about the color of those ones. But if we can do this without soldering, then I don't have to desolder one that I'm going to reuse. So desoldering one to reuse is what I'm kind of thinking the most about. Okay, that's free. Those are kind of, I'm going to be careful with those cables. So now that that's free, I can get to that screw. Oh, you're in manual. Oh, and when it's in manual, all the settings only show up over there. Okay, let me just unplug the HDMI so I can see what's going on. Movie auto exposure. Okay. Oh no, we were in manual. We were just auto ISO is what we were. ISO to auto. Okay, cool. So that way we maintain manual shutter and aperture. And let's go up to 30. So we got ourselves a circuit board here. Now the question is, can I remove the lid without removing the board? Okay, so first thing I'm noticing, oh, cool. Both of those are like one strand away from breaking, so that just snapped. That was solid core, so that's pretty brittle, and that other one's definitely gonna snap too. That's easy to resolder though, so we will be resoldering that. And the one that snapped off is not the one that was in service for the issue. That's the one that's used for the suppression voltage. So the suppression voltage is not applicable here. So even if that one was having a connection issue, would not have been an issue. So the ones you are sealed relays. Okay, so I'm already noticing that these do not appear to be very sealed, which is kind of interesting to me. So if we look at corners of those cases, it's not really a lot of sealing going on. I don't think these are hermetically sealed relays by any stretch of the imagination. But that kind of gives me hope for being able to very gently, basically, pry open one of these. Yep, let's do that. Okay. Oh, yeah, that lid's coming right off. Oh, that lid's coming off super easily. Yeah, look at that. Okay, it's just, maybe it's like plastic sealed on the inside and just the outside is metal. I don't know yet, but whatever part is on the outside is coming right off. No, there's no other plastic case. That's just the whole thing coming off, it looks like. I think. It's the whole thing coming off. Okay, so that's our coil. I guess the reeds are in the middle of that, it looks like. So it's interesting. The instead of like one side being coil and one side being the relay, it's that pin and that pin. So the long ones are coil, and this side is relay. Okay, so now that we're on the bench and we can get to the pins, let's do the test that we wanted to do earlier, which was the do we measure, oh, other cable finally broke as anticipated. Let's do the resistance test across the contact of this relay and see if we can see something. Okay, we are in auto range. Auto range is in 500, and I'm not getting anything. Yep, not seeing anything. So that's measuring completely open. So if there is a problem, it's happening at high voltage, which does line up with us seeing this thing like kind of happen as intermittently as we have been seeing it. So I'm guessing the contacts are in the middle of this coil. So if that's the case, I can't really do any kind of visual inspection or service on the contacts. I just got to like pull the relay out. So some of the leads are like folded over, which is going to make extraction slightly more challenging, but shouldn't have too much of an issue here. Let's get our soldering tool out. Yeah, they are in the core of the coil. So no readily user serviceable contacts in this one, we'll say. see here, that power strip might be too far away for us. Yep, that power strip is too far away. I got one down here I can bring on over. Okay, that's almost close enough. If we just bring that over like that, there we go. Got that where we want it. And I guess we can switch to, oh, we already switched to a different main camera. Okay, cool. Let's get this out. Let that warm up. I'm gonna grab a wet, or some, well, what do we want to do here? We'll do a paper towel. Oh, we got the, I know, we got the perfect thing. Perfect thing. Got our distilled water. So this is what we're going to use to clean off our iron. And let's go at it. So definitely gonna start with trying to desolder the one we're not going to use again. Yep, as anticipated, the folded lead is causing some headaches. I might just cut the folded lead off. Whatever I do, I want this to be a strategy that we're using to extract the next one. Because we need to be very gentle with our next one. Yeah, I think cutting the lead off is feeling like the right move. Even if the lead's straight, it has to come out so far that it's kind of causing additional effort and additional potential for damage. Okay, I need a little bit of extra solder on that one. Let's go ahead and just cut the lead off now. We still have enough to solder with. We just want to make extraction easier and less likely to cause damage. There we are. Give it a little snip, snip. Also makes it less likely that we damage the PCB. And it's important not to damage the PCB because we are reusing, we're reusing this part of the PCB, that's for sure. Come on, are we heating up? Are we melting? Doesn't feel like we're melting. Okay, a little bit more solder. Just a smidge more solder. Here, let's make sure, so that random short piece, let's use the spool of stuff so that we know we are using something with a no clean flux. Not that we're not going to clean it, it's just that I don't, underneath the relay, if we get anything there, I don't want that to cause an issue in the long run. Okay, relay extracted. We're definitely going to want to figure out how to remove the next one in a more gentle fashion, because this one, we did bend the legs a little bit, but that, honestly, the amount that we bent the legs should not be enough to damage this in a way that causes challenges for us. So, And we're not reusing this one, so I guess we'll go ahead and open it up. Yeah, look, that's the coil there. Love to see that. Yeah, we're not getting to the reads on this one very easily. Still kind of want to. But I feel like to do that, we're going to have to unwind that whole coil. We'll leave that intact for now. Okay, so we're going to pull out 8 is the plan, right? Let me check the schematics, just double check, make sure that it is indeed the one that we want to go ahead and remove. Yeah, I think we're going to pull out number 8. Okay, so relay 8 is that one. So what does our lead situation in relay 8 look like? Okay, we got one folded over. So we're going to go ahead and snip that ahead of time this time. Get nice and low there. Snip. What is chat saying? Yeah, no, a sealed glass vial inside the coil would make a lot of sense. I could absolutely see that being the case. Okay, let's carefully extract it. Let's clean our iron right before we use it. Okay, I can feel it moving pretty easily. We're going to try and pull this one out as straight as possible with as little heat as possible. It's coming out nice and evenly, it feels like. I get in a little bit more every time we go kind of around, doing kind of round robin type thing. We're really close to having that fully extracted. Okay, that one, so this one corner, this back left corner has not actually been moving nearly as much as all the others, so let's work on that one a little bit. There we go. there we go. Okay, that's almost out. 3 are out. Come on, last one. Yes, sir. Yep, there we go. Okay. That is a very gently extracted relay, if I do say so myself. So now let's get the holes on 2 cleaned up. I got the solder sucker right here. So put some fresh solder on there. Did a pretty good job. I think we'll go ahead and heat from the back and then pull the solder out the front. Oh yeah, that did a great job. Okay, cool. Okay, let's okay. Oh, I can see the soldering from through the board actually. That's cool. Okay, we're heating, and sucking it. Okay, cool. Another clean hole. And I got one more to go. Well, actually, we're going to redo the first one because this from the heating from the back technique is working really, really well, and just a little bit better than how the first one went. But the first one was completely serviceable. Okay, I can see the iron. Okay, I need a little bit more solder in that one. Oh, we're liquid. Maybe a little bit more off the edge. What's going on? It's an angle issue. Why was that one a little bit more challenging? I also got those wires right there. Okay, that's better. Those wires out the way. Okay, no problem this time. Okay, and we'll go back to the first one again. Cool. There we go. And I think we're going to put this in and then wrap the stream up there for now. We'll be back on later tonight. I'm just going to head out for a bit once we get this soldered. Oh, I do like the conditioning idea is a good idea. I'll have to consider that. I think we could come up with a way to doing that. I think of several already. Let me just there's a little bit of solder in there. I'm going to wipe off with some ethanol. Clean up where we just worked. Okay, trying to get some globs of solder off of where we were just working. Well, yeah, thank you everybody for joining the stream. I think our plan is to be back a bit later tonight. You all have been so great. I appreciate all the feedback, and we'll definitely be sharing some updates with you on what happens. If anybody's got any questions, comments, ideas, feedback, or anything, now is a great time to throw them in the chat because we're going to be wrapping this up pretty shortly here. Okay, got the leads cleaned up. Let's get them kind of bent straight here. Oh, the other one's maybe need to be bent straight. That one's just a little bit, but I think that's from the install. Okay, the relay's back in. Make sure I got the orientation right. Orientation's good, and let's get that soldered. Okay, that's back in. Cool. Well, thank you so much, everybody, for joining the stream. Really had a great time with you all here. And I think with that, oh, the donor relay came from relay 8. And the most patient died. I can't quite read, it's really small. Yeah, it came from relay 8 on this board. Well, with that, we're going to wrap the stream up here. We'll be getting back on later tonight, but yeah, I will catch up with you all later. Thank you so much for all the help, and I will talk to you all soon. Bye.